Hello guys and welcome to the Unreal Engine 5 Blueprint Beginner Tutorial. In this beginner tutorial, I'll explain what are blueprints, why you should learn blueprints, and how to use blueprints inside of Unreal Engine 5. Blueprint is the visual scripting system of Unreal Engine, and you can use Blueprint to create things like complete games, tools, and so much more. Now, if you aren't going to be creating games inside of Unreal Engine, blueprints still can be a very useful tool to learn, whether you're using Unreal Engine for creating things like short films, or maybe even creating some sort of interactive product for a client. You can still use Blueprint to create tools or interactability, so it can be very useful to learn for all aspects of Unreal Engine. Now, before we continue, we should probably address the elephant in the room. Recently, Epic Games announced that they eventually plan to deprecate blueprints in later versions of Unreal Engine 6 as they transition to the new gameplay framework verse. However, they also confirmed that blueprints will continue to be supported in the early versions of UE6, so this isn't something that's going to happen anytime soon. Based on what Epic has shared so far, this transition is expected to be more than half a decade away, and even after that begins, there will still be many UE5 and UE6 projects, studios, and indie developers using blueprints for many years to come, so taking the time to learn them today, in my opinion, is not a waste of time. Personally, I also wouldn't be surprised if Epic eventually introduces another visual scripting system very similar to blueprints, based on how the community responded to the news. But regardless of what happens in the future, the concepts that you'll learn in this tutorial will help you better understand how Unreal Engine 5 works and make learning future systems much easier. Now, in this video, we'll be going over all of the blueprint basics inside of Unreal Engine 5. I'll explain how to create blueprints, all of the user interface in the blueprint editor, what are blueprint variables and how you can use them, and we'll apply all the things that we learned by creating these 5 different blueprints. So we have things like a door that we can open and close. We have this health and damage boxes. When our character runs into the damage box, it will decrease their health. If we run back into the health box, it will heal our character. We have things like this hat pickup that we can equip to our character. We also have a soccer goal that we can score the ball in and it will respawn, and just so much more. So this video was designed for complete beginners with no experience. However, this is the second video in my Unreal Engine 5 beginner series. So if you don't have Unreal Engine 5 installed, or if you are a complete beginner with UE5, I recommend that you watch my previous video where I show you how to get started inside of Unreal Engine. It teaches you the bare basics of the editor and all the basic controls. Now, if you do reach to the end of this video and you end up enjoying this free tutorial, you can check out some of my premium courses on smartpoly.teachable.com. If you are interested in making games inside of Unreal Engine, luckily for you, I have a complete multiplayer survival game course where we create a complete multiplayer survival game from scratch, and I'll be adding more courses in the future, so chances are if you're watching this video in the future, you can check out my website smartpoly.teachable.com to check out if there's any new courses. Now, this is the first video in my Blueprint Beginner series, so I'll be making a follow-up video called Blueprint for intermediate users. So this will be the second blueprint video in the series, and after that I'll be making a third and final video called Blueprint for advanced users. So make sure that you hit that subscribe button because you don't want to miss out on the follow-up tutorial. Also, I'm trying to hit over 200,000 subscribers by the end of the year, and so without further ado, let's go ahead and jump right into the video. Alright, so go ahead and launch Unreal Engine 5.8, and then over here we're going to create a new project. So select new project, and we're going to select the third person template under the games category. And over here, we're going to leave it as blueprints and leave it as the defaults. We're going to leave the variant as none, and we're going to rename the project to Blueprint Tutorial and just click create. So now that we're in here, let's go ahead and take a second to actually explain what are blueprints. So blueprints are the visual scripting system of Unreal Engine. You can use blueprints for a lot of things. You can create things like full complete games using blueprints. In fact, there are games like Expedition 33, which was comprised of 95% blueprint code. But you can also use blueprints for other things like creating tools, interactive experiences. There's just so many different possibilities. So now that we've explained what are blueprints, let's go ahead and check out a simple blueprint. So if we go into our content drawer, we have a folder for third person, and in here we have blueprints. Let's go ahead and dock this in the layout, but in here we have a third person character blueprint class. So if you've played this template before, if you click the play button, basically you have this third person character where you can run around and jump, and you have this camera that moves around the character. So that character is powered and created by Blueprint. And over here, this is the actual Blueprint class, the BP third person character Blueprint class. So let's go ahead and actually open this up and see what is inside. So double click, open this up, and we're going to go ahead and take this window and dock it up here at the top. Now I'm going to go ahead and explain everything that we see here because it might look intimidating at first. So the first things that I'm going to focus on over here are these tabs up here at the top. So the first tab over here on the left, let's go over to the left, we have the viewport. So just like our editor viewport, we have this viewport inside of our blueprint. So I can right click inside of here and use WASD to move inside. We have all of our basic movement controls and viewports, view modes, okay? In here, you're gonna notice that our character has a couple of different assets in here. We have this character mesh. I can actually select in here and select different objects. So we have this character over here. I select the character. You can see we have a movement gizmo, so we can actually move things around in here. We can, scale things up, all that stuff. Basically, the viewport just shows us what the blueprint consists of visually, okay? So a blueprint can have components that make up a blueprint. So this viewport basically just shows us the visual side of the blueprint. Now, to the right of that, we have this construction script. Okay, so we have basically like this graph, blueprint graph. This is actually where we can program some nodes, okay? Now, we'll touch more about the construction script, but basically this construction script gets run before the game starts, okay? Now, to the right of this construction script, we have these move and aim functions. So you can see we have move and aim. And basically this is where our character's movement and aiming logic is. And these are just functions that contain those logic, okay? So now to the right of those functions, we have the actual event graph. The event graph is more important because this is where everything is stored, all the events, all the main blueprint logic. And to navigate in any blueprint graph, you can scroll in and out with your mouse wheel. So use the mouse wheel to scroll in and out. And you can use the right mouse button. If you hold down the right mouse button, you can grab the graph and pan around. Okay, so scroll and pan around. Now on this event graph, basically everything that our character can do, things like moving its camera around, moving the character, jumping, all of that is powered by these nodes that you're seeing here on the graph. So for example, we have things like our jump. So we have these nodes over here, which is a red input node, our input jump. So when we press the space bar, we call our jump function, which will make our character jump in the air. And then when we stop pressing the space bar, it stops jumping, okay? So everything in here are just a couple of nodes connecting with wires. That's all that blueprint really is. Okay, so those are the main tabs up here at the top. Now you can close some of these tabs. So for example, the move and aim, we can close those tabs. And we'll come back to that in a second. But those are the three main tabs. We have the viewport, the construction script, and the event graph. Now over here on the left, we have this components window. Okay, so in order to showcase this, let's head over to the viewport tab. But over here, this components tab over here basically just lists all of the different types of components that make up our character visually. So again, if I select on this character model over here, you can see that it's highlighting this mesh, character mesh. So the components list is similar to, our world outliner over here, where it's just a list of all the different things in our level. In this case, it's a list of all the different things in our character blueprint. So you can see we have things like the capsule component. This is the actual, character simple collision, basically. Okay, we have the arrow. This is just like a visual, which direction is forward for the character. The mesh is our character's actual character mesh. We have the camera boom. Basically, this component sort of is like an arm. It shows us how far the camera should rotate around the character. And then we have the actual follow camera. So remember, when we're playing the game, this is where we actually see our character from. And then lastly, in our components list, we have a character movement component. So this component is built into the character blueprint class. Basically, it handles things like the character jumping, moving, all that stuff, okay? So the components just lists all of the different types of systems that make up our character blueprint. Also, when we select different components, you'll probably already notice that we have this details panel over here on the right, which takes up this right half of our screen. So depending on what type of component we select, for example, if we select the mesh, you can see that we have various different details depending on that component that we have selected. So if we have the character mesh selected, we have things like the transform, so the location, rotation, and scale. So if we, modify the location, you can see that I will modify, the character location. I'll reset that back to 0. We have the rotation and also the scale. So if I modify the scale, you can see we can modify the scale of our character. Okay. Now, if you modify any values like this, you can always click on this back arrow over here, and that will reset it to the default value. Now, down here, we have other things like the actual skeletal mesh, the character mesh reference. So if you wanted to swap this out for a different character mesh, you do it right here. And we also have things like the materials. So there's more other different details, but those are some of the main ones. And again, if we select different components, it will show us various different details for that component. Now down here on the bottom left, we have this window, and this is the My Blueprint window. Basically, what this shows us are the graphs. So we have our event graph over here. You can see we have the event graph. Now, if you, for example, accidentally close this event graph window, if you close that tab, you can always come back to it by clicking on this event graph over here on the graphs. Now, below that, we have functions. So functions are basically sort of like subgraphs where you can store and nest certain logic. So remember how we had the move and aim logic? We had those different functions. If I click and open it up, it'll show us this move function, which has some nodes in here. Okay, we can close that and it's right here. So these functions are just right there. Also, we had the construction script. It looks like it accidentally closed the construction script. So if you want to get back to that, again, you just open it up like that. Okay, I usually like to have mine sorted out like this: viewport, construction script, and event graph. But below that, we have things like interfaces. So we'll go over interfaces in the Blueprint for Advanced video. We have things like macros, which are sort of like, shortcut functions, which are similar to functions. Then we have variables. Variables are what we're going to use to store information about our character, like our health, items, all that sort of stuff. Okay. We have event dispatchers. Again, we'll cover this in the Blueprint for Advanced. But those are kind of the main windows, okay? Now we have this top bar here. Let's go ahead and actually talk about that. So we have the save button. Okay, we have the browse. So this basically will just browse and show us where that third person character blueprint is located in our content browser. Then we have the compile button. So whenever you make any sort of changes in your blueprint, whether, you take this character and move it around, or whether you actually, delete some of these nodes, it's going to have this question mark compile icon. Basically, what that means is whenever you make any sort of changes, you'll need to compile your blueprint to see if there's any issues or errors. So you just hit the compile button, and then you can see now it's green, which means it's good to go. It's compiled, and you can save it just like that. Now to the right of this, we have this diff button. So if you have revision control where you can, back up your project to the cloud and also collaborate with team members, you can compare changes in this blueprint against previous versions. Okay, we have find. So this will basically kind of search through your blueprint for certain functions. We have hide unrelated. So this is hide unrelated nodes. I don't really use that too much. Class settings and class defaults. This will just show us the different settings for this third person character. And then we have things like simulation. So this will just simulate the blueprint. And then to the right of that, we have our play button options. So similar to this built-in play menu over here, like playing our game, we have some quick access. So if you click the play from here, it'll launch this new editor window, which is also very nice and convenient. That way you don't have to go back to over here and click the play button. So just nice that it has those options. Okay, and then debug object selected, we'll come back to this later. So those are kind of the basics of the window. We have the event graph, we have the viewport, the construction script, the components that list out the different systems that make up our character. We have details. that show us various different details about those components. And then of course we have the My Blueprint, which shows us the different graphs and variables. So now let's go ahead and actually create our very first blueprint class. So let's just close out of this character, and in this third person blueprints, we're going to make our very own blueprint class for the very first time. So let's right click in here. And in order to create our own blueprint class, we have under the basic asset types, we have this blueprint class. So let's select that. Now, when you create a blueprint for the very first time, it's going to show you this window that pops open, which says pick a parent class. Now, basically in blueprints, there are a couple of different parent classes that you can pick from. You can think of these sort of as like preset options to choose from, okay? So we have at the very top, we have this actor. An actor is an object that can be placed or spawned in the world. So basically an actor is the most simplest version of a blueprint, the most generic type. So you can use this sort of for like doors, interactable objects. Basically, if it just needs to be placed or spawned in the world and have some sort of logic attached to it, you can use an actor class. Okay, below that we have a pawn class, which is a little bit more advanced than the actor. In this case, a pawn is an actor that can be possessed and receive input from a controller. Okay, so this pawn, you would use this for creating things like maybe vehicles. You could also create things like planes, cars, even, mounts, like a animal mount, any sort of blueprint that might need to be possessed by a controller. So let's say, we have a plane that the player can run up to and fly in. You'd use the pawn class. Now, we have below that a character class, which is a type of pawn that includes the ability to walk around. So basically, the character has the built-in character movement component that allows it to, walk around and all that stuff. So you can kind of see how we have, different types of these presets. And then below that, we have some more different types of blueprint classes. So we have this player controller. This player controller is an actor responsible for controlling the pawn used by the player. As you can see in our third-person character blueprint, we actually have a third-person controller. You might not use this class that much in single-player games, but you will use this when you're creating multiplayer games. Also, the game mode base. This is another class. The game mode base defines things like the rules, the scoring, and other facets of a game type. So if you're going to be making things like games, especially multiplayer games, typically you're going to be using this game mode base class because this game mode base is going to store the rules of the game. Okay, then we have other things like actor component and scene component. So if you wanted to create a custom component, you can do so and use this actor component. Now for us, since we're just going to create a very simple generic blueprint, we're going to choose the actor type over here. So we're going to select that and it's going to spawn in this asset in our content browser. Let's rename this to BP underscore my first blueprint. And then just double click and open this up. Okay, so let's go ahead and take this window and dock it up here at the top. And one thing that I actually like to do is instead of manually having to do this every single time, like dock this up at the top, you can go to your editor preferences over here. And if you go down here to the asset default open location, you can set this to main window. And that will just prevent us from having to manually dock our blueprints up there at the top. Okay. Now, as you can see, if I actually close out of this, let's talk about that real quick. If I close out of that blueprint asset and reopen it, when you create a new blueprint class for the very first time, you might have this view. Okay. So you can see it's different from this third person character blueprint. You can see we have the graph over here, but if I open our first blueprint, we have like this list. Okay. And basically this says, note, this is a data only blueprint. So the default values are shown. It does not have any script or variables. If you want to add some, open the full blueprint editor. So all you have to do is click on this and it's going to open up the full blueprint editor. Okay. So that's basically what that means. Now, so here's our very first blueprint. We have our own viewport over here. We have the construction script and the event graph. Right now, everything is completely empty. You can see it has nothing visually. Okay, we just have my first blueprint. And then we have like this default scene root. It's sort of just like the scene itself that we have here. So let's actually add like a visual to this blueprint, our first blueprint class. So in order to add our own visual or own asset into here, you just click on this plus icon, this add, and you can see that we have a list of components to add to our blueprint. So we can add things like audio, we can add things like a skeletal mesh, this is like a character mesh. Static mesh would be like a prop. We have some different shapes, like cube, plane, sphere, but we also have some advanced things for AI, animation, audio, camera, all sorts of different components to add in here, okay? So for us, we're gonna just add a simple sphere over here. So choose the sphere. So we have this simple sphere mesh component over here. So now we have a visual representation of our blueprint. So if we were to actually put this in our level, for example, if we go to a third person level, you can see that we now have this visual updated. We can just drag and drop this, and you can see that it has that visual, which is this sphere mesh. Okay, that's our blueprint. Now let's go into the actual blueprint because we want to add some basic logic inside of here. So in order to do that, we want to go over to the event graph. And over onto the event graph, when you create a new blueprint class, it's always going to have these 3 nodes when you start off. And we're going to cover over these other 2 later, but let's just focus on the first one. So let's go ahead and drag, and you'll notice that when we left click and drag, we can actually select nodes, and we'll just select those and delete. So right now, let's just focus on this event begin play node. So this event begin play right now, it's disabled. It's grayed out because there's nothing hooked up to it. So let's go ahead and actually add some basic blueprint logic. So we'll take this execution, we hover over this little triangle over here, and if we click and drag, it creates this wire. And if we actually drop it on the graph, it will pop open with this list. Okay, so the list has a ton of different things, but basically this allows us to search for a node that we want to execute. So we're going to search for the print string node. So we have this development print string, and we're going to go ahead and select that. And now you're going to notice that it ungrayed out the event begin play. And now we have these 2 different nodes connected together by this execution wire. Let's go ahead and move this up like that. So now let's take a second to actually explain what's going on here. So this event begin play node, this event gets called when we actually play the game. So when I click on this green play button, this node will get fired off, okay? And then you can see that this wire basically shows us the flow of execution, which means it will start over here from the left, and then it will go over to the right. And when the game starts, when we hit play, it will fire off this next node, which is called the print string node. Now, this basically just prints onto our screen this text over here, which says hello. So that's all that blueprint is. We have nodes, a series of nodes connected by a series of wires. And in this case, the execution flows from left to then right. So now whenever we create any sort of changes in our blueprint, when we hook up nodes together, you want to come up over to the compile button, and you can see the compile has that yellow question mark. So you want to hit the compile. Now it says green, it's green, good to go, and then save that, okay? And now to actually test out our very first blueprint, when we hit the play button, it should say this hello. We just go to our level. You make sure that you have your blueprint in the level. So we already dragged it out here and spawned it. And then we can go ahead and just hit the play button. And you'll notice that it says hello up at the top screen. So let's go ahead and press escape and play again. And it says printed off hello up the top left. So basically all that this little sphere blueprint is doing is inside of here when the game starts, it's just printing off hello. Okay. And we could even modify the text in here. So if we wanted this to say, hello world, we could modify that. And again, whenever you make any sort of changes in your blueprint, you want to go up here to the compile button, hit the compile and save. And then we can go into our level and hit play. And it says hello world. Okay, so it's updated the text. So that is our very first blueprint. All that it has is this sphere that we've added as a little simple component. And then in the event graph, it just has these two different nodes. When the game starts, print off hello world to the screen. So now let's go ahead and talk about variables, because variables are very important for blueprints, because variables are very important for blueprints. Essentially, variables allow us to store various different information about our character or about our blueprint. So we can store things like our player's name, the health, how many items they have, if they're dead. Variables basically allow us to store various different types of information. So let's go ahead and create our very first variable. So down here under the My Blueprint tab, we have a section for variables. And in order to create a new variable, we have this plus icon. So just click the plus icon, and what you'll notice is it created this new var. And so we can actually rename this by highlighting the name, and we can change this to is dead ? Now, the very first variable type that we can create is this Boolean, okay? There's more other different types. By hitting this drop down, you can see that we have a lot more different types, and we'll talk about these here in a second, but let's first talk about the Boolean variable type. So once you have this Boolean variable selected, in the details panel, you'll notice over here, we have some details about this variable. So we have things like the variable name, the variable type, but most importantly down here, we have the default value. So in order to actually set the value of this Boolean, it says, please compile the blueprint. So we'll need to go over to the compile button, hit the compile, and now you'll notice that we have this is dead, and then we have this checkbox, okay? So basically, a Boolean is a true or false statement. So what that means is right now, is dead is set to false. We can hover over it, it says false. But if I check that little checkbox, it now says true. Okay, so basically a Boolean is a true or false statement. It can either be true, checked like that, or false, unchecked. Okay, so let's actually go ahead and get this Boolean variable on our graph. So in order to actually get this onto the graph, you just drag from the variables, and then you can drop it on the graph, and you actually have two different options. Okay, you can get the is dead variable, or you can set it. In our case, we just want to get it for now, so we're going to select get is dead. Okay, so now we have our actual Boolean variable on the graph, and next up what we want to do is we want to unhook this wire over here, this event begin play to print string. So in order to break the connection, you can hold down the Alt key on your keyboard and click on the wire, and that will break the connection. So off of this is dead, I can drag off it, and it also creates a wire. And if I drop it on the graph, you can see that we have that same exact menu that we saw earlier. And so what we want to add is called a branch. So search for the branch. We have this flow control branch. Okay, so we want to go ahead and select that node. And basically what the branch does is it checks a condition, and the condition is a Boolean variable. Okay, so it's either true or false. And as you can see, what it does is it has these three different execution wires. So we can take our event begin play, and when the game starts, we're going to hook this up to the branch. So now when the game fires off, when the game starts, it will call this branch. And basically what the branch does, it just checks and sees if this Boolean variable, if this is either true or false. Okay, so right now this is set to false. So let's check this to true. And now what's going to happen is this branch is going to check the condition. In this case, it's set to true. So it's going to fire off this true wire over here. Okay, so we can go ahead and plug this into our print string. And then basically we're going to go ahead and rename this text to our player is dead, ! Okay, and then if this is false, what we want to do is we can select this node, this print string node. We can copy it by doing Control-C, and then paste it by doing Control-V. Okay, and then hook this up for the false. And let's change this text down here. So select that and change this to our player is not dead, just like that. So basically now what we're doing is we're checking to see if this condition is our player dead. If that is true, it's going to print off our player is dead. Now, if I uncheck this for the false, what it'll do is it'll call our player is not dead. Okay, so let's go ahead and compile and save this. And now if we go into our level And because we have our blueprint already placed in here, if we hit play, it's going to say our player is not dead. And that's because over here, this is set to false. Okay, so now if we were to come in here and change this is dead to now true, hit the little checkbox, hit the compile and save, it should print off our player is dead. Let's go ahead and hit play, and it says our player is dead. So that's all that a Boolean variable is. This is just a true or false statement. And then the branch node is usually what you'd use to check that condition, whether or not it's true or false. And you can call different nodes depending on that logic, okay? So that is a Boolean. Let's go ahead and move on to the next variable type. Let's go ahead and under the variables over here, we can add another variable. So click the plus icon. And in this case, we're going to name this to money. And for this variable type, we're going to hit the drop down and we can change the variable type down here. So we have Boolean. We're going to skip over byte. Byte is basically like an 8-bit number. So if you want to store like a number that is only 8 bytes, you could use that. I don't really use it that much, but we have integer over here. So we're going to select integer. And basically, integer is any sort of whole number that you can use to store a value. Remember, whenever we create a variable type over here in the details panel, it's going to show us the different details like the name, the type of variable, but also the default value. And again, we need to compile the blueprint in order to set the value. So let's compile it. And now we can actually set the value. So currently this is our money integer. Basically, we can go ahead and type in here any value that we want, but you need to note that the integer is a whole number. So what the integer is we could type in 5,125, but it is not a decimal number. So I can't do 1.5, 22.7. You're going to see that it won't allow us to type in decimals, only whole numbers. Okay. So if we wanted to actually print off this, money integer to our screen, what we can do is let's go ahead and just delete what we currently have. So delete all this. And then we're going to go ahead and hook up our event begin play to our print string. And let's get our integer money on the graph. So just drag and drop it on the graph. And again, we can either get it or set it. In our case, we're just going to get that variable. And in order to actually print this over here, what we can do is take this money integer and drop it on the string. And it's going to say convert integer to string. So if we drop it on there, it uses this convert node, which basically takes in this integer, which is this number, and converts it to a string, which we can actually print. So now what we should see is it should print off this number 22. So compile and save. And if we hit play, it will print off that number 22 to our screen. Okay. So basically, an integer you can use to store all sorts of variables. It can be things like ammo, money, any sort of whole number. So now let's go ahead and add another variable type. And in this case, this is going to be our health. And for this different type, let's change this from integer over down here to a float. So let's go ahead and select that. And now you can see the float is color coded with this light green color. And again, in order to set the default value, we'll need to compile the blueprint. So hit the compile button. And this value, basically a float allows you to set any sort of, whole number or even decimal number. So I could do, 25.7. I could do 1.5, any sort of decimal number, 0.009. It will allow us to do that, okay? It could also be like a whole number like 15, just like that. And so for float variables, you can use this for things like damage, health, all sorts of stuff like that. So, we could print this off. Let's say I have 100 HP. And so compile that. We can hook this up to our print string as well. So let's delete this node over here and the money. And if we grab our health float variable, we can get that on the graph. And again, just like the integer, we can just convert this to a string. So if you just drag and drop it on the string, you can see that we can convert this float decimal number into the string to print off. So let's compile that and let's also save that. Hit play, you can see it prints off that float, which is 100. Okay, so that is the float variable type. Let's create another variable over here. So add another variable. This one is going to be a string. So we could just name this, my string, and change this over here to a string and compile and save. And now when we compile the string variable, we can actually set the default value. And basically a string is a string of text. So for example, we could type in whatever. It can be, letters, it can be numbers, it can even be special characters. So like star, asterisk, exclamation mark, $sign. It could be basically anything. So if we were to delete all this, all the nodes, and actually grab our string on the graph and drop it, we can get it. And then we can just plug this into the string. And since these are of the same variable type, there doesn't need to be any sort of conversion in between them. Okay, so compile and save, and now it's going to print off this string of random characters or values. Okay, so if we go ahead and hit play, you can see that it prints off the string on our screen. Okay, so string variable type is very useful if you want to store things like maybe the player's name, because it can support all these random characters, numbers, all that sort of stuff. Okay, let's go ahead and create another variable over here, and let's talk about the vector variable. So we're going to name this to, my vector, and we're going to change this from a string over here, and we're going to change this from a string. You'll notice that we have these other different types right next to the string, like the name and text. The name variable type is used more for, bow names and things like that, but this isn't necessarily like player names or anything like that. This is more or less for certain names on, your character's bone, on your character mesh. We also have text. So again, text is sort of like a string, but in this case, text is more or less used for like widgets and user interface. And then below that, we have the vector. So this is what we want to select. So let's select that. You can see that the vector is color-coded with this yellow color. So if we compile this, a vector is basically comprised of 3 float values. So you can see we have an X, a Y, and a Z. And actually, to demonstrate the vector a little bit better, let's actually head over to our character blueprint. So let's go over to our third-person character blueprint and open this up. And so in our character blueprint, what we're going to do is add a vector variable. So add a new variable in here. We could, name this teleport location, and we can change this from a Boolean type to a vector and compile and save. And so for this vector, what we're going to do is on our event graph in our character, we're going to add an input. So we can right click on the graph and open up the window, and it's going to allow us to search for any node. So we're going to search for the R key, and we should have a keyboard event, a key for our R key. Okay, so just look for the R key over here. We're going to select that. So whenever you press the R key on your keyboard, we can call some logic. So what we want to do is grab our teleport location. Okay, we're going to grab our teleport location and drop it on the graph. And instead of getting it, we're going to set the location variable. So what this set node allows you to do is actually set the vector variable. So instead of just setting it over here in the details, you can actually set variables during runtime. So we're going to hook this up for the pressed. And then for this location, what we can do is right click and get our actor location. We have this node called get actor location, which basically gets the location of our actor. Okay, so select that, and you can see that the target is our actor, which is this character, and it returns a vector variable type. So we can actually plug this into this vector teleport location because it's the same type of variable. So now when we press R, basically we're getting our location, we're setting our teleport location, saving that variable reference, and then we can also print this off. So if we search for the print string, the development print string node, we can select that, and then we can hook up the execution. And for the string, we can hook up this out. Okay, basically the set variable also has an out. So if you drop it on here, it will convert that to a string and it should print it off on our screen. Okay, so now we can just compile this character blueprint. So just hit the compile and save. And when we press the R key, it should get our location, save that, and print that off. Let's go ahead and press play. And if I press R, it's going to print off our location. Okay, if I move around, you can see that it's changing the location if I just spam it. based on where our player is located. So if I go right over here, that is our location, the X, Y, and Z. If I go over to here, it's going to be a different location, okay? So basically that is what a vector variable is. It's just a X, Y, and Z coordinate, which you could use to store things like, the player's location and all that stuff. Okay, so now let's go back to our third person character. And over here, we can add another variable. And this is going to be a rotator variable. So let's just name this to my rotation. And we can change this from a vector over to a rotator. Okay, so what a rotator is, let's just compile and save this, is basically is three different float variables, but in this case, they are rotations. So if we go in our viewport here and select our character, you can see that we have the rotation over here. Basically, this is a rotator. We have our character rotated 270 degrees on the Z over there. So if we were to rotate our character, negative 90 on the X, you can see this will update the rotation value, okay? So basically, a rotator is just the rotation of a object, okay? Now let's go ahead and talk about the last variable type. So let's add another variable. This will be a transformation. So let's name this my transform. And we're going to change this over to the transform variable type. So let's compile and save. This variable type is color coded with orange. And in the default value, since we compiled our blueprint here, we can expand this. You can see basically a transform is just a location, rotation, and scale combined together, okay? So just like our character mesh over here, this character mesh has a transform, a location, rotation, and scale. That's basically all that this is. We have a location, rotation, and scale value. Now we've primarily gone over how to get variables on the graph. So for example, if we were to go back to our first blueprint over here, we can get all these variables on the graph by dragging and dropping it and getting our is dead. We can drag our money variable, get that on the graph. We can also get our health variable, drop that and get the health. We can also get our string over here, and then we have our vector over here. Okay, so we can get all of these variables on the graph, but we can also, in addition to getting the variables, we can also set them. So we can just grab our is dead variable, drop this on the graph and do set is dead. So, instead of getting the variable, we can actually set the value of this variable during runtime, okay? So we can set that to is dead to true or false, vice versa. We can also set our money variable. So we can grab this, drop this on the graph and do set. And we could set our money amount. So, we could set this to like $1,000, okay? We could also set our health over here. So if we get our health variable and set it, right now it's 100 HP. Let's say we set this to, 50. We can even get our string over here, get that on the graph and do set. We can set that to, player name. And also our vector, we can set this on the graph and set, our location to maybe 0, 0, 0. And so now you should understand all the different variable types. Okay, we can get all the variable types. We can get the values of them. And then we also have all the different set nodes, so we can set the values during runtime. So now what we're going to do is we're going to pivot and we're going to start creating our different blueprint classes for all the different examples in this tutorial. So we're going to first start by creating a door blueprint that the player can open and close. So for that, let's go ahead and go over to our content drawer here and dock this in the layout. And so for this, we'll need to add some starter content. So for this, you want to go to the link in the description of this video and download the starter content from the Google Drive link. And then you'll download the file and you'll just right click and do extract to extract the contents. And basically once you extract the files, you should have a folder like this, starter content, which inside has some architecture, audio, blueprints, props, all that stuff. Okay, so in this folder, in our project, we want to right click in the content browser under the content and do show in Explorer. This will show us where our project is stored on our computer. In my case, mine's on my E drive, Unreal Projects, blueprint tutorial, and then in the content folder. Okay, make sure that it's like this. Okay, again, that's just right click the content, show in Explorer, and that will pop it open. Then we're going to take the starter content folder, make sure that it's this folder over here, starter content, and inside of it, we have all the subfolders. Make sure that you copy this folder, not this folder over here. Okay, make sure it's the starter content right here, copy, paste it into the content, and then in that content, starter content, you open it up, it should have all the subfolders just like this, okay? If you do it the wrong way, if you copy this folder and it says starter content, and then the subfolders, then the asset paths and everything will not work properly. So just make sure that it's the proper path like this, okay? So now that we've added that, we can go back to our project over here, and we should see a new folder for starter content. And in there, we should have some props, which we can use for this tutorial. Okay, so for us, we're going to make a door that the player can open and close. And in the props folder, we have the door mesh that we need to use. So let's go ahead and create the actual door blueprint. So let's go to our content folder here, and let's right click and create a new folder for blueprints. Okay, and then we can open up that folder. And in there, we're going to create a new folder. So create another folder. We'll name this 01 underscore door blueprint. And then double click and open that up. So in here, we're going to need to create a new blueprint for our door. So just right click and create a blueprint class asset type. And for this, we're going to choose the actor because we just need a simple generic actor that can be placed in the world. That way we can have some basic blueprint logic set up. So select that. And then for this blueprint name, we're going to name this BP underscore door. Okay. So now let's go ahead and just double click and open this up. And in our blueprint door, we're going to need to add a couple of components for our door and door frame. So over here under the components, make sure you're obviously in the viewport tab so we can see what we're doing. In the components, we're going to click the plus icon and add in here a static mesh component. Okay, because we're going to need one for the door frame. So let's right click and we can actually choose to rename this to our door frame. And then with this door frame static mesh component selected in the details, we can actually set the static mesh. So over here under static mesh, we can click the drop down and we're going to search for the door frame mesh, the SM door frame. Okay, so we should have now in this viewport, this door frame in here. Now we just need the actual door mesh. So let's select the door frame and add another static mesh component. And this one will be named door mesh. Okay. So now with the door mesh component selected in the details, we'll set this static mesh to the door. And we should have this SM underscore door. Okay. This glass door over here. So now we just have to move this to line it up. So press W on your keyboard to get the movement gizmo. We'll just move this over. Now you'll notice we can't place this exactly where we want it, so we'll need to turn off the grid snapping. So you come over to here, and we can turn off the grid snapping by clicking that little icon. So now it's white, so we turn off the snapping. Now we can position this exactly where we want this to be lined up, okay? So something like that. Now we can compile and save, and now we've basically set up the door frame and door mesh. Now what we want to add is we want to add some sort of collision or trigger box so that when the player gets close enough to the door, we can actually interact with it. So for that, we're going to go back to our components, and we want to make sure that we first select the default scene route over here, or just the door. Because the reason why you want to do that is because depending on where you select, what component you have selected, will determine where your component will be added onto. Okay, so there's sort of like a hierarchy here, if you haven't noticed. So if we select this door at the very top, we can add and search for a box collision, this box collision component. And you can see that it's added onto the default scene route right next to the door frame. Okay, if we were to have this selected, this box would be underneath the door mesh, which would mean that it would be attached to the door mesh. We don't want that. Okay, we want it to be up here. So now with this box collision selected, let's actually go ahead and right click, rename this. Let's just name this to our interaction box. Okay. And let's go ahead and actually scale this up. So over here to scale this up, let's press R on the keyboard and scale this up by just dragging the boxes. Press W to move, R to scale. And we could basically scale this up to, something like this. So essentially when the player gets close enough to the door, when they're in the interact box, then they can actually interact with the door and press the E key to open or close it. Okay. So let's compile and save. We've added all of our components. Now we need to actually set up the blueprint logic that drives the opening and closing the door. So we want to go ahead and head over to the event graph to add those nodes. So now over here in the event graph, what we're going to do is, again, we have these basic events when we create a simple actor. What we can do is drag and select these and delete them because we're not going to be using them, and compile and save. And what we're going to do instead is we're going to use this interaction box. Okay, so this, trigger box over here, we're going to use this to detect whether the player is actually inside. So for that, you want to head over to the event graph and select the interaction box. And over here in the details, if you scroll all the way down, we have these different events for this interaction box. Basically, we have this on component begin overlap. So if we click this plus icon, it's going to add this red event node that gets called when something overlaps with the interaction box. Okay, and you can see that we have an execution, but we also have a bunch of other different pins. Okay, so the pin that we want to check is if it is another actor, in which case if it's the character. So we're going to use this other actor since a character is technically also an actor. Okay, it's not a component. A component would be, like this blueprint component. So we're going to check and see if this other actor is a character. In order to do that, we're going to search for the cast to third person character. So we have this cast to BP third person character node. So if we select that, you're going to see that it automatically hooks up the execution, but also this object, which is the reference. Okay, so basically what this cast to BP third person character does is it checks and sees if this overlapped actor, is it the third person character? Okay, because remember the third person character blueprint, this is our character over here. Okay, BP third person character. So we're basically checking to see if the actor that's being overlapped with the box, is it our character? If so, then this pin will be called over here. If not, it's going to call this cast failed. Okay, so for the true, basically we want to enable input for our door so we can open and close it. So we're going to use the enable input node. You can right click and search for enable input. We have enable input over here, and if we select that, we can hook up the execution. So hook up this execution just like so. We only want to hook it up for if it's true, if it is our character, because if this cast failed, that means it's not our character, so we don't want to enable input. Now, in order to enable input, you also need a player controller reference. So remember, player controller is the class that controls the character. So we're going to right click and search for the node get player controller. So we have this get player controller node. We're going to select that, and basically it just gets our current player controller and returns the reference of that. So we can plug this into the player controller. So basically we're enabling input for that player controller for this door to actually interact with the door. Okay, now what we want to do is when the player actually leaves the interaction box, so let's say they come up to it and then they walk away, we want to disable input. So we basically want to do the opposite of this. So for that, we want to select our interaction box again, and we should have on component end overlap. So we can click the plus icon, and that will add an event for when we end overlap. So just like what we done up here, we're going to, off of the other actor, check and see if our character is the one that's leaving the box. So do a cast to third person character node. And then basically if it is our third person character, instead of enabling input, we're going to disable input. So right click and search for disable input, disable input. Okay, so we're going to hook this up for the true. And then for the player controller reference, again, we need to get our player controller. So we can actually just hook this up like so, and that will work completely fine. You could also copy and paste this down here and have another one, but this will work completely fine. So now let's compile and save, and now we have some basic logic where if the player overlaps with the box, we enable input. If they leave the interaction box, we disable input. So now we just need to add a simple input key in order to actually rotate and open the door. So down here, let's right click and search for the E key, and we should have keyboard events. If we scroll down, we should have a key for E. Okay, so we have our E input key. When we press the key, we want to go ahead and open the door. So for this, we're going to use a flip flop node, and we have this flow control flip flop. So what this flip flop does is when we press E, it's going to call A. When we press E again, it's going to call B. And this will kind of open and close the door. It'll kind of give us a flip flop where the door is open and then it closes, then it goes back to open and closes. So that's basically what the flip flop does. So for the A node, what we want to do is rotate the door open. So we want to get our door mesh over here. Basically, want to just take this door mesh, and if you press E, we want to rotate it about 90 degrees, just like that. Okay, so its current rotation right now, if we look at the rotation over here, is set to 0. But basically, we want to rotate it on the Z axis only negative 90 degrees, just like this. Okay, so in order to do that, we want to head over to the graph, and we want to grab our door mesh component. So we can actually grab this on the graph and get it, just like a variable. And then we can actually just drag off here and search for the set relative rotation node. So we have set relative rotation, and basically we can actually just set the rotation of that component. So hook this up for the A, and for the rotation, we want to set this Z value to negative 90. Because remember, in the viewport, if we actually take this door and rotate this negative 90 degrees, this is the open position. Okay, so that value, negative 90, is what we want for this open position. Okay, now if we want to do the opposite of that and close it, we can select both the nodes by dragging, do Control-C and Control-V to copy paste, and then hook this up for the B. But in this case, we want the door to be closed, so we're going to reset the Z value back to 0. Okay, so essentially when we press E, that should open the door, set it to negative 90 for the rotation on the Z, and when we press E again, it's going to flop down to B and reset the rotation back to 0. So let's compile and save, and now let's head over to our level here. And in order to test this out, let's go over here. I'm going to delete this sphere that we have, but let's basically just place our door down here, okay, just in the level. And make sure that you compile your door blueprint, compile and save that. And let's go ahead and actually test this out. So let's hit play. So we should be able to run up to the door. We're now overlapping with the box. So if I press E, it will open the door just like that. We can walk through. And we can press E again, and that will close the door. So notice how it flops. Basically, if I press E, it'll open. E again, it will close. That is our basic logic. And now if I run away from the door and try to press E, it's not going to let me open and close the door. Only if I'm in the trigger box will it let me open or close the door. Okay. Now, one thing you're going to notice right off the bat is if I actually run up to the door, we can actually run through the door. Okay, now this actually has to do with the collision of the mesh. So let's go ahead and actually fix that. So in order to fix that little bug, all you have to do is go to your door, select the door mesh over here. And one neat thing to do is to browse to where this is located. You just go over to the static mesh. And you can click on this little browse icon, this folder magnifying glass. So you click on that. It will pull up the content drawer, pull up where it's located, and then just double click and open up the static mesh. So this will open up the static mesh editor. And in here, we can go ahead and modify the collision. So up here under collision, we can add a box simplified collision. Okay, and that will add a box collision. Now you'll notice that the collision is thicker than the actual door mesh. So what we can do is actually select this by clicking on here, press R, and we can scale this thing down. Okay. We'll need to turn off the snapping though. So come over to the snapping and turn off the scale snapping. And now we should be able to scale this down something like that. I think that's a lot better. So then just save that and close out of there. And now if we go back to our level and hit play, we can walk up to the door and we can no longer walk through the door mesh, okay? So that is our very simple door blueprint. It just opens and closes. Now what I want to modify about this blueprint is the fact that right now the door just snaps open and close, okay? It just goes from 0 to -90, and it doesn't really have like a natural smooth rotation. So we're going to go ahead and modify that by adding what's called a timeline node. So let's head over to our door blueprint and head back over to the event graph. And what we're going to do is we're going to modify this part of the code where we just set the relative rotation, okay? So let's go ahead and add a timeline node. So down here, let's right click and search for add timeline. And down here at the very bottom, this add timeline, we want to select that. Okay, so we can rename this timeline. It's going to ask us to add a name. We're going to just name this door rotation timeline. And basically the timeline allows you to blend between two or more values. So if we actually double click and open this up, that's going to open up this timeline node up here. And over here right now we don't have anything in it, so we need to add a track. So over here we can click the plus track and we can add different types of tracks. In our case, we just want to add a single float track. So add a float track. And you can add a name for the track. I'll just leave it as is. But basically in here, this is a simple graph, okay, which has, different coordinates. And we have two different values. We have the X value and the Y value. Basically, we have a length of the timeline. So for this length, we're going to modify the length over here to be 2 seconds long. So the length is in seconds. And then we're going to add some points to the graph. So right click anywhere on the graph and add a key or a new point on the graph. And that exact point, if we select it, it should be highlighted in blue. We can set a time and a value. So for this first point, we want to set the time to be 0 and the value to be 0 as well. Okay, so we should have that set to 0, 0 right there. Now right click anywhere else on the graph and add another key. And for this value, you can select this. We want to set the time to be 2 seconds. And then for this value, this needs to be the rotated position. So we're going to do 90 degrees, just like so. And then you're going to see if we actually zoom out, our point kind of disappeared. So in order to resize the graph, you want to click on these two buttons, zoom fit horizontal, zoom fit vertical. And now we can actually see both of the points. Okay, we have 0, 0, and we have time 2, value 90. So basically all that the timeline is going to do is it's going to play and output a float value based on this timeline. So at 0, 0, it's going to output 0. At 1 second, it's going to output the value 44. At 1.5 seconds, it's going to output the value 67.3. And at 2 seconds, it should output the value 90 degrees. So basically, you should gradually output a value and gradually transition from 0 all the way up to 90. Now, in order to actually smooth this curve out, to give this a lot more smoother effect, you could select both of these points by shift selecting. Okay, so both of them should be highlighted, and then right click one of them and add a auto key interpolation. So what that does, it should add this nice smooth curve, and it will just add a nice smooth door animation. So let's go ahead and compile and save. And now that we've set up this timeline, we can actually close out of here, and we're going to use this timeline to update the rotation. So over here for the flip-flop, we can unhook the A and B. So hold down Alt and click. Alt and click, that will break the execution there. Let's delete one of these nodes. We only need one of these set relative rotation. And let's pull up our door rotation timeline up here. So for the A, what we're going to do is plug this into the play from start. That will play our timeline from the start. And then B, when we want to close it, we're just going to plug this into the reverse from end. Okay, just like that. And then to actually set the rotation for that, we'll plug in the update to the set relative rotation. And then this new track 0, this is what's actually outputting the rotation value. So in order to modify our door rotation, what we're going to need to do is we only want to modify the Z over here of this rotator. So we need to actually break or make this rotator. So drag off of here and we can search for the make rotator. We have this vector make rotator down here. And basically what that does is it sort of like splits a rotation value into 3 separate floats so that we can only affect one of the floats. In this case, we only want to affect the Z value because we only want to rotate the door on the Z axis like this, okay? So we're going to plug in this new track 0, the output, into the Z, and that should update the relative rotation over here every frame when this timeline is getting called. Okay, so now basically we have our E. So when we press this, it's going to play the door timeline from start. So at 0 seconds, it's going to output value 0. Then at 1 second, it's going to output value 45. So you can see that it slowly rotates the door all the way out to the open position. So by 2 seconds, it should rotate and set and output the rotation value to 90 degrees, which should be open. So let's compile and save and actually test this out. Let's go to our third person level and hit play. And if we run up to the door and press E, it should slowly rotate like that. And press E, it will rotate like that. Okay, so now we have a basic door open and close animation using a timeline that basically outputs a nice smooth door open and close animation. Okay, so basically that's what the timeline node allows you to do. It allows you to sort of blend between 2 different variables, and it gives you that nice smooth animation curve. Okay, so that's our very basic door blueprint. We're going to move on to the next blueprint, which is going to be a hat pickup blueprint. And this is going to be very similar to our door blueprint where we have a interaction box. But in this case, when we walk up to the hat pickup, we press E. It's going to equip a hat to our character's head. Okay, so for this, what we'll need to do is you'll need to go ahead and download the Blueprint Beginner assets. So it should be the second link in the description again. So you'll just go to the Google Drive link and download the assets. So you should have this Blueprint Beginner folder. Just right click and extract the files. And so in here, this is going to be some separate assets, just a ball mesh, hat mesh, and some other different assets that we're going to use. So for this, we'll go to our content drawer here and dock this in the layout. In this one, we're not going to drag the folder into the directory. What we'll do is we'll actually manually import these assets. So let's just, in our content folder, let's create a new folder for meshes. Okay, just like that. Double click and open that up. And then in here, we can just select all of the assets. And since these are all FBX files and we have a texture file there, we can just drag and drop them into the folder. We're going to leave this as the default settings. We won't change anything. We'll just click import. And that should import all the assets just like that. Okay. So let's go ahead and save all these because they have all the save icons. We need to save them. So do file, save all. And that should save all the assets. And so basically we're going to use this static mesh hat, this little hat model, and use that for our hat pickup. So let's go over to our blueprints folder. And let's right click and create a new folder. And this is going to be 02 underscore hat pickup blueprint. Okay. And just double click, open that up. And so in here, we're going to right click and create a new blueprint class. And for this, again, we're going to choose the actor blueprint class because this is going to be just a very simple hat pickup. So let's go ahead and select that and let's rename this to BP underscore hat pickup. Okay. And let's just file, save everything. Okay, so go ahead and open up this BP hat pickup. And in here, we're going to head over to the viewport. And we need to add the actual hat mesh. So let's add under the components, click the plus icon and add a static mesh component. This, we can rename this to our hat mesh. And then with this selected, let's go to the details panel. And under the static mesh, let's click the drop down and search for the SM underscore should have our SM hat model, okay? So just like that. So compile and save, and then what we want to add is a little collision sphere so that when we overlap with it, we can actually pick it up. So we're going to add under here, instead of using a box, we're going to use a sphere. So search for sphere, we should have this sphere collision. So select that. And then for this, we can actually rename this to, interact sphere, like that. And we can also scale this up. So if we press R, we can scale up the sphere, compile and save. And if we actually just drag this in our level, we can see how big this is. Okay, I think that should be good, just like that. Okay, you could scale up the hat mesh if you want it to be bigger, but I think that's great. And then also I'm going to add a little text, a little interact text. So under the components, let's actually just select the default scene root here and add in a text renderer component. So basically this is just a simple, text over here. So we're going to select that, and in the details over here, we can change the actual text. So select this. We'll name this, press, and then in brackets E to pick up. Okay, and you'll see the text over here. So we can press E and rotate this 90 degrees. And then if we want to center the text, we just come over to the alignment over here, and we can change this from left to center, and that should center up the text. And then we can also move that up like so. So let's compile and save, and let's see what that looks like. Okay, we have press E to pick up. I think that should be good for now. Okay, so now in this hat pickup, we want to actually set up the logic to actually pick up the hat. So again, we need to head over to the event graph. Again, whenever you create a new actor blueprint class, it's going to have the default nodes. So we can just select these, delete those. We don't need those. And then in here, we're going to add sort of the same setup that we had with our door blueprint. We basically want to detect whether or not the player is overlapping, within the range so that they can actually interact with the hat and pick it up. So for that, we want to select our interact sphere, that little interaction sphere over there. And then in the details, let's scroll down, and we should have a on component begin overlap. So let's add the on event begin overlap. Let's also select this and add the on event end overlap. Okay. So again, same sort of setup. We basically just want to check and see if the actor that's overlapping with this interact sphere, if it's the character. So do a cast to third person character. Make sure that's the character and not the game mode. Okay, third person character. And then we want to go ahead and enable input. So just right click and search for enable input and hook this up for the true. And then for our player controller, we can just search for our get player controller node and then plug that in for the player controller reference. Okay. Now when we leave the interact sphere, we want to basically do the opposite. So again, cast to our third person character. Check and see if it's our character that's leaving the interaction sphere. And then we want to do the disable input node and hook that up just like so. And again, we want to hook up the player controller reference so we can disable the input. Okay, so compile, save, that's our basic setup. Now for our E, to actually pick up our hat, what we want to do is we need to go ahead and set up an event inside of our character in order to actually equip the hat to our player. So we're going to head over to our character blueprint. So you can head over to your character. If you still have it open, you can just head over there. But if you don't, just go to your third person blueprints, open up the third person character blueprint, just like that. We want to head over to the event graph, because in the event graph, we need to add an event for when we actually pick up the hat and equip it to our player's head. So down here on the event graph, you can go below this, right click on the event graph and search for the add custom event over here. So we have this event, add custom event. So if you select that, basically we can add our own custom event where we can name it whatever we'd like. So we'll name this to, equip hat. And the thing about events is that you can add inputs and basically pass information to this event. So what I mean by that is over here under the details, we have things like the name of the event, but also down here under inputs, we can click a plus over here to add a new input. And now we can actually pass variables through this event. In our case, we want to pass the hat mesh. So over here under the Boolean, we want to change this to our hat mesh. So we want to search for static mesh. We should have a static mesh object reference. Okay, so we want a static mesh object reference. And then we want to go ahead and rename this from new parameter to hat mesh, just like so. So basically, we want to pass the static mesh, the hat mesh, over to our character. That way we know what hat to equip to our character. So now whenever you add a custom event, you want to make sure you compile and save. That way it actually, sees the new event. And so for our pickup hat event, basically we want to call this from inside of our BP hat pickup. Okay, so let's go back to our hat pickup. And so when we overlap with the hat and enable input, we want to call our, E key. So we should have a keyboard event for E. Okay. When we press E, then we want to go ahead and call that pickup hat event from inside of our character, this equip hat over here. Okay. So in order to actually do that, we can cast to our character, and we'll need a reference. So down here off this other actor, we can drag off here and cast to our third person character over here. And we want to plug this in for the pressed. Okay, so when we press the E key, we're going to cast to our character. And basically, if this is valid, if we do have a valid reference to our character, then we're going to call that equip hat event. So in order to call that, we have this reference to our character, which basically means that we can call any sort of event or retrieve any info from the character. So if you drop this on the graph, we can call and search for that equip hat event over here and select that. And now you can see we're actually calling this event over here from our character from our hat pickup. Okay, so compile and save. And now we can actually set the hat mesh. So if we click the drop down, we can set this to that SM underscore hat mesh over here. And now we're basically passing that hat mesh over to this event over here. Okay, let's go ahead and just compile this real quick. And then let's go over to our character and finish off this logic, because now that we're passing that hat over, we want to go ahead and actually attach this to our player's head. So for this, what we're going to do is we're going to go ahead and go to our viewport. And in here, we're going to select our character mesh component. Actually, just select our capsule component over here. And we're going to add a static mesh component. Okay. And for the static mesh, let's rename this to, hat mesh, something like that. Compile and save. And now that we've added that, we can go to the event graph and get this hat mesh. And basically, we want to set it. So we can do a set static mesh. We should have this set static mesh function. Basically, this allows us to set the static mesh to whatever mesh we want. So in our case, we can hook up the execution. And for the mesh, the new mesh that we want to set it, we want to plug in our hat mesh just like so. So compile and save. So now we're actually setting this hat mesh component to the mesh that we're receiving from our pickup. Now we just need to make sure that it's attached to our player's head, because right now it's not attached, it's over here. Okay, so in order to attach it, what we're going to do is we're going to get our hat mesh on the graph, get the components, and we want to search for the attach component to component node. So this function attach component to component basically attaches one component to another component. So in our case, we want to attach the hat mesh component to our character mesh component. So let's grab our character mesh, drop it on the graph, and plug this in for the parent. So we have the target, what we want to attach, and we have the parent we want to attach to. Okay, so let's hook up the execution and compile and save. And in order to actually do this properly, we want to set this to location rule, snap the target, rotation, snap the target, and scale, snap the target. So let's compile and save, and let's actually go ahead and actually test this out. So we have our hat pickup. Basically, when we overlap, we enable input. And when we press E, we call this equip hat inside of our character. We set this static mesh component to our hat mesh, and then we attach it to our character. So let's go ahead and hit play in here, and let's just see what happens. So if we run up to our hat mesh and press E, you can see that it attaches it to our character. However, it's not attached to our head. It's not actually lined up with our head. Okay, so in order to actually attach it to our head, what we'll need to do is add a socket so that it will attach perfectly to our head and not, to the bottom of our feet like that. So for sockets, what we'll do is we'll head to our third person character, select your character mesh here, and in order to find where it's located, you just browse to the skeletal mesh asset. So click on the browse icon here. And then we can actually just pull up the character mesh by double clicking and opening the asset up. Okay, so basically socket allows you to attach various different things to your character. You can use it for weapons, armor, hats, all sorts of things. So in order to add a new socket to our character in our skeleton, we have all the bones over here under the skeleton tree. We can take this window and expand it, but we should have a bone for our head. So if you scroll down in this list, it will show you all the different bones that make up our character. And we're going to look for the head bone. So I found it. We have this head bone over here. And then onto that head bone, we want to add a socket. So just right click that and we have the option to add socket. So select that. So for this head socket, we're going to double click on this and rename it. We're going to rename this to our hat socket. Okay. And so we have our hat socket. That's great. Now we can just copy this name and then go back over to our character, head back to the event graph, and then over here under the attach component to component, under this socket name, we can now paste that socket name into there, and now it should attach that hat mesh to that hat socket. So compile and save. And also an important thing to note is that this needs to be the exact capitalization, punctuation, and spelling as what you have over here, okay? So just make sure that it's the exact same. So let's go ahead and test this out. Let's hit play. And if we run up and press E, it attaches it to our head, but you'll notice that it's not lined up still. So in order to actually get this perfectly lined up, we can go back to this skeletal mesh asset. And one easy way to fix this is you just right click the socket, the hat socket, and you can actually add a preview asset, and you can search here for our static mesh underscore hat. We should have our hat static mesh. And now we can actually preview where it's going to be attached on our character. And if we press W, we can actually move this up on our head, and press E, we can actually rotate this. So press E, we can rotate this 90 degrees. And press W, we can move this like so. And again, you can turn off, the snapping, and we can basically position this where we want it to be at. So I think that should be a good position. In order to save this, let's click the save button there. And now it should actually save this offset, okay? So let's go ahead and hit play. Let's go and pick up the hat. And now you can see it's actually on our head. Okay, so we're using that socket. We set the socket offset so that it's perfectly positioned on the player's head. Now the last thing that we'll need to do is make sure that when we pick up the hat, we need to delete this pickup because it's now on our head. So we need to go ahead and delete this actor from our level. So for that, let's head back over to our BP hat pickup. And after we've called our equip hat function, we can drag off here and do a destroy actor node. Okay, so what the destroy actor node basically does is it just destroys and deletes this hat pickup from our level. Okay, so removes it from our level. So let's compile and save. And now when we pick up the hat, we destroy it and delete it from the level. So let's hit play here. Run up to the hat pickup, press E. You can see it deletes it and removes it from our level because now we have it attached here to our head. Okay. So that is our very simple hat pickup. We have a simple collision sphere. We overlap with it. We can equip it. Basically, equipping sets the static mesh component and it attaches it to our head at that socket location. Okay. So now let's go ahead and create our very next blueprint. So for the next blueprint, what we're going to create are the damage and health boxes. So let's go to our blueprints folder and let's right click and create a new folder here. And we're going to name this 03 underscore damage box. Okay. And double click open this up. Let's just dock this in the layout. Okay, so in this folder, we're going to create our health and damage boxes. So basically, we're going to have two separate boxes. One of them is going to heal us, and the other is going to damage us. And we're going to apply some damage to our character, and then have a health bar widget display the actual health on our character screen. So we're going to right click, create a blueprint class of the type actor. We're going to name this BP underscore damage box. Okay. So this will be our damage box. Let's open this, double click, open this up. And then in here, what we want to add is a simple box collision. So under the components, we're going to add our box collision. Okay, just like that. And that should be good. We'll compile and save this. Let's rename this box over here to damage box. Okay, just like that. And then let's head over to the graph over here. And here we're going to delete all these nodes. So just select and delete those. We don't need those. We're going to be using the overlap event. So we're going to select our damage box and scroll down. And we should have the event on component begin overlap. Click and add an event for that. So off of the other actor, again, we're going to check and see if this is our character. So we'll do a cast to third person character node. And then basically we want to go ahead and actually set our character's health. So for that, we'll need to actually add a health variable to our character. So what I'm going to do is I'm going to close these other blueprints and just have our character and this damage box open. So let's go to our third person character blueprint. And then in here, we're going to add a new variable. So click the plus icon over here, and we're going to add a new variable for our health. Okay, so this will be our health. And this will need to be a float variable. Okay, so let's compile and save. We want to compile this. That way we can set the default value. So the default value of our player's health will be 100 or, 100 HP. So compile and save that. So now that we have a variable for our health and our character, we can go back to the damage box. And now because we're casting to our character, we can get that health variable. So drag off of the reference, we can now get the health, which will retrieve that health variable. So we can get that, and now we can actually, modify this. So since this is a damage box, we want to basically, subtract our health. So what we're going to do is take our health and subtract this, and we're going to damage this by, say, 10 units, just like that, okay? So 10 HP, we're going to take our health, which is 100 minus 10, and then we're going to have to set that to our new health. So in order to actually set our health, we can, again, get off of our character reference. And in this case, we want to set our health variable, so we can set the health. So now we just plug in the execution. So we want to hook this up like that. And then we want to take our health minus 10 and set our health to that variable. Okay, and in order to actually see this happen in action, we want to print this. We're going to do like a little print string. So what we'll do is we'll search for the print string node over here, and we'll hook this up, and then we'll take our health and plug that into the string, and that should convert the health into a string, okay, just like that. So let's compile and save, and now let's actually go ahead and test this out. So basically when we overlap with this damage box, right now it doesn't really have anything, any visual to it. It's basically going to get our character, get the health, subtract 10, set our health to that, then print that off to the screen, okay? So let's go ahead and actually browse and find this damage box, drag this in our level here. Okay, and let me move the door out of the way, and let's actually scale this up, okay? So we might scale this box a little bit larger. Okay, now if we actually hit play in here, we might have a hard time finding where our damage box is at. So one thing that we can do for now is if we go in our damage box in the viewport here, select this damage box components and search for in the details hidden. We can uncheck the hidden in game, compile and save. And now if we hit play, we should be able to see this little box in game. So now we can run up to it and it's going to say 90. But as you can see, it doesn't actively damage our player. So what that means is I can only overlap with it. I have to re-overlap for it to subtract 10 HP. So subtracted again is 80. Now it should say 70. Then it should go down to 60. Then 50. And so on. Okay. So we want to go ahead and modify this because we don't want it to just subtract every time I overlap. What we want to modify this to do is that it can keep subtracting our health as long as we're in this damage box, okay? Because we want it to actively damage the player as long as they remain inside of the damage box. So in order to do that, we need to go back to our damage box, head to the event graph here, and instead of doing it this way where we only subtract 10 health once, we're going to delete this. So let's select and delete this. Instead, what we're going to use is a timer. So first things first, let's actually get our character over here. And we're going to save this reference. So in order to actually save this character reference, you can just drop it on the graph. And the neat thing about this is you can just promote this to a variable. So if you click that, what that does is it automatically creates a new variable of the type third person character, just like so. So now if we compile and save, basically what we're doing is we're taking our character reference and saving this as a variable over here. Okay, so we can actually right click and rename this to, character ref, compile and save. And then now what we want to do is we want to actually go ahead and add a timer by event. So basically timers allow you to have sort of like a tick event where you can call an event over and over and over, which is what we want for our active damage loop. So we're going to do a set timer by event node. So the set timer by event. And basically this gives us this event that we can add to basically bind to the event we want to loop. So drag off of this event and drop it on the graph. And now we can add an event over here, add a custom event. So select that. And for this custom event, we can name this, damage player. Okay. And then what we want to do is over here for the time, we want to set this to every 1 second. So this is how many seconds you want it to loop. And then of course you need to set this to looping for true. Okay. And then this event over here will basically be called every 1 second over and over. Okay, so now for this event, what we want to do is off of here, we actually want to get our character reference. So get our character reference and get that on the graph. We want to use the apply damage node. So if we drag off our character reference, we can search for apply damage. And Unreal Engine comes with these built-in apply damage nodes. So the engine comes with these built-in damage nodes where you can apply damage, and it's very useful for, applying damage, receiving damage, and all that stuff. So we're going to go ahead and select apply damage, and now we can hook up the execution just like this. And then basically the only thing we want to change in here is the base damage. So we could say we want to subtract, 10 or apply 10 damage to our character. And that's all we have to do, okay? So let's go ahead and compile and save. And now in order for this to actually apply damage to our character, we need to go into our character blueprint because we need to set up the receive damage, okay? So remember how I said that there are built-in functions for this? We just right click and search for event any damage. And again, we have built-in function, this event any damage, so select that. And basically, whenever we apply damage to this character blueprint, this event any damage will be called. So now what we can do is we can get our health variable. We can drag and drop that, get that on the graph. And now we can actually subtract this, do a subtract this by the amount of damage that we're going to apply. Okay. And now before we actually set our health, we actually can, just get our health on the graph, set that. Before we just plug this in just like that, what we want to do is we actually want to make sure that we clamp this value. Okay, so let's first hook up the execution. So what I mean by that is we don't want our health to go into the negatives. We don't want to keep subtracting and go all the way past 0 into -10, -20. What we want to do is we want to use a clamp node. So off of our health, we can search for a clamp float You have this float, clamp float. And then basically what we can do is plug in this for the value. And then we can have a min and max value by which we clamp it by. Okay, so our minimum will be 0. We don't want to go in the negatives again. And then maximum will be whatever your max health is set to. So in our case, it's set to 100 HP. Okay, so what this will guarantee is our health won't go below 0 or above 100. Okay, so it'll basically clamp the float in that range. And then of course we can print this off. So we'll do a print string node, and we'll hook up the execution and plug in this output into the string so that it will print that off. Okay, so let's compile our character. Make sure that you also compile your damage box. And now basically when we overlap with the damage box, we're going to start this timer where we fire this apply damage off every 1 second. And then in our character, we basically get our health minus and subtract that damage, set our health variable, and print that off. So let's go ahead and hit play. And now if we run up to the damage box, as long as we stand in here, it's going to say 90, 80, 70, 60, 50. And it should go all the way down to 0, but not in the negatives. So now it says 0. And you can see that it's not going below 0. Okay. So now what we want to set up is we need to actually set up the end overlap, because right now, if I leave the damage box, you can see it's still subtracting our health. So we need to go ahead and stop the timer when we actually leave this damage box. So let's go back to the damage box blueprint, and you can see we didn't add the end overlap. So we need to select our damage box and add that. So let's scroll down and add our on component end overlap. Okay. And what we're going to do is we're going to first, again, off of the other actor, just cast to our third person character. Make sure that this is our third person character that's leaving the damage box. And then if so, we need to stop this timer over here. So in order to actually stop this timer, you can actually save the timer reference. So off of this return value, this gives us a reference to this timer. So take this return value, and again, we can promote this to a variable. So click on that, and we can rename this reference down here our timer ref. Okay. So then let's just compile and save. And then we need to go back down here. And now that we have that timer reference, we can just drag and drop this, get this on the graph. And there's this neat node that's built in. We just call it. It's called the clear and invalidate timer by handle. Basically what this does is it stops this timer. Okay, so we're going to hook this up just like so. Okay, so compile and save. So when we leave the damage box, we stop the timer, which will stop calling this apply damage every 1 second. So now let's go ahead and test this out. Let's hit play. We'll run into the box. We'll get damaged by it a couple of times, 80, and if I walk out of the box, you can see that it stopped. So if I go back into it, it should say 70. Now if I run out of there, it should stop damaging our player. Okay, so that is our damage box. What we want to add now is we need a visual for it. Right now it doesn't have anything. It's just this, box. So we need to add some particle effects for this. So go ahead and head over to fab.com. Make sure you log in with your Epic Games account. We're going to search over here for the FX Variety Pack. So search for FX Variety Pack. It should be this one over here. So it should be free for you to use. You go over here and add this to your library. So you head over to the Epic Games launcher, and over on the Unreal Engine library tab, you'll just refresh your Fab library here to sync it. Since you just added that FX Variety Pack to your library, you just need to resync it. Okay, so it should refresh and grab that and add it to your Vault cache here. Then you can just search for the FX Variety Pack and you should see it right here. Okay, so you'll just add this to your project. Click on Add to Project. You can do Show All Projects. Okay, make sure that you click that check, Show All Projects, and then search for the Blueprint tutorial version 5.8. Okay, so make sure that you show all projects, select it, and just click Add to Project. Okay, just like that. Then in our content drawer, we should have a new folder here for FX Variety Pack and a bunch of different particle effects in here. So what I'm going to use for our damage is this magic circle over here. So we're going to go into our damage box, into the viewport, and add over here a new component. you can search for the cascade particle system component. So we're going to select that, just like that. It should say particle system. And then in our content drawer here, these are all cascade particle systems. So these are actually old legacy particle effects. The new particle system is called Niagara. So again, these are legacy. So these are like older, but they still work fine in Unreal Engine 5. So we're going to select this, red magic effect. And then in our damage box, what we can do is actually select the particle system. And over here under the particle template, we can hit this arrow, and that will automatically assign that asset. So if you have it selected in your content drawer like that, you can just hit that arrow and it will assign that asset. So a little neat hotkey there. So now we just need to scale this guy down because it's a little bit too big. So for the scale, we're going to lock this scale and do 0.27. Okay, so it should scale all three of them at the same time. 0.27, 0.27, and 0.27, just like that. Okay, also I'm going to take this damage box and just move this up like that. And then we can search for the hidden in game. We can check that back to true. Okay, so now if we go into our level here and hit play, we should just see this damage particle effect. So if we run into it, it starts damaging our character. So now we want to add a heal box or health box, basically that will heal our player. So we're going to go back to our content drawer here. Let's go to our blueprints, damage box, and in here we're going to add basically the same thing, but it's going to do the opposite. So I'm going to right click, create a new blueprint class of the type actor, name this BP underscore health box. Let's double click, open this up. And then again, same thing, we're going to add some components. We're going to add a box collision. This box collision will be called our heal box. Okay. And then also let's add a particle cascade particle system component. For this one, we're going to go to the template here and search for aura. We should have this heal aura. Okay, so select that just like so. And again, let's scale this down. So click on the lock icon for the scale and set this to 0.27. Okay, let's just select this box collision and move this up. And you can see because this particle system is actually parented to the health box, it's moving it with it. So let's take this and drag and drop this onto the default scene root. So now we should be able to move the heal box independently. Okay, just like that. Okay, so I just move that, compile, and save. And now let's go to the event graph, delete these nodes. We don't need these. We want to add the overlap for our heal box. So select the box collision. Scroll down, we should have the on begin overlap. So let's add that event. And then also let's select the heal box again and add a event end overlap. So just like what we did with the damage box, we're going to do pretty much the exact same logic. So off of the other actor, we can cast to third person character. And then of course, we'll take the character reference, promote that to a variable, and we're going to rename this to character ref. Okay. And now that we have a reference, we can go ahead and do our timer. So we're going to call the node set timer by event. Okay, just like that. And then we need to add an event to bind this to. So drag off of this, drop it on the graph, and add a custom event. Okay, this custom event will be called heal player. Okay, we want to set this time to loop every 1 second, and then we want to set that to looping to true. Also, we want to save a reference to the timer. So drag off the return value, promote that to a variable, and name this to the timer ref. Okay, just like that. So compile and save that. And then down here, we want to, instead of apply damage, we want to basically add health to our health variable. So we're going to get our character reference down here, and basically get our health variable. And then we want to just add to it. We want to add 10 HP to our health. So we're going to take our health and do a add, this operator add, and then just add 10 to our health. Okay, and then in order to actually set our health, we can just drag off of the character reference here and do a set health. So we can actually set the health float, okay, variable, and then drag and hook this up for the execution. And then before we actually hook this up into here, we want to make sure that we again clamp the float. So remember we did this in the character. Well, we want to do it here. We want to make sure that we do a clamp float over here. That way we don't heal the player more than 100 HP. So we'll plug in the value. For the min, that will be 0, and the max will be the max player's health, which will be 100 HP. Okay, so that way it's capped at that value, and our player doesn't heal above 100 HP. So now let's compile and save. And now that we have the heal looping effect done, now we need to set up what happens when the player leaves the box. So in this case, we want to, off the other actor, cast to third person character. Make sure it's the character that's leaving the heal box. And then we're going to get our timer reference on the graph and clear and invalidate the timer by handle, just so we can stop our passive heal. So let's compile, save, and now we should be all set. So when we overlap with the health box, we start our timer, which every 1 second we basically add 10 to our player's health, just like so. And then also, if we wanted to visualize this, we need to print this off. So what we'll need to do is do a print string, and let's plug in our health to the string just like so. Let's compile and save. And now let's go to our content browser here. I'm going to move a couple of things over. We can drag in our health box. We'll scale this up to the same size. I think we did 2.8 for the scale over here. So we can right click and copy the scale, select this health box, and in the scale here we can right click and paste it so it matches the same scale as our damage box there. Okay, so let's save that and let's go ahead and hit play here. So now we have our two boxes. We have our damage and our health box. Let's go ahead and damage our player. We have 90, 80, 70. Now if we go in here, we should heal up to 80, 90, 100. And again, you'll notice that it caps our health at 100, so we can't heal above 100 HP. Okay, so again, we could run over here, damage our player down to 80, and we can go all the way back up to 100, just like so. Okay, so those are our health and damage boxes. The last thing that we want to do is we want to add a little health bar widget to our player screen. So in order to do that, we're going to be using the Unreal Motion Graphics, or UMG system inside of Unreal Engine, which allows you to add different types of, health bar widgets, player UI, all sorts of stuff. So let's go to our content drawer here, stock this in the layout. Let's go back to our damage box folder here. And in here, we're going to create a widget blueprint. So right click. And for this, we're not going to select blueprint class because the widgets are under user interface. So if you scroll all the way down in this list, you should see user interface down here at the very bottom. We're going to select this widget blueprint. Okay, widget blueprint over here. And then it's going to ask us to pick a parent class. We're just going to use the default user widget. Okay. And then over here, we're going to rename this. You can usually name this, widget blueprint underscore, and then the name of the widget. In this case, it'll be called our health bar. Okay. And then let's just double click and open this up. So if you're new to widget blueprints, if you haven't messed around with user interface in Unreal Engine, basically this is like a simple UI editor. So over here in the graph is basically going to be the visual representation. You can sort of think of it as like the viewport. And this is where we'll add things like our health bar, stats, all that stuff that's going to be on the player screen. Okay. Over here on the left, we have this palette over here. Okay. Which basically has different types of things like buttons, progress bars, sliders, text, all sorts of stuff that we can add onto it. Down here, we have the hierarchy. You can kind of think of this as like the components, where it has like a list of all the stuff that you add. And then we have, of course, a details panel over here. Okay, so let's go ahead and build out our health bar widget. So the first thing that we'll need to add is you want to go over to the palette over here and search for a canvas panel. Okay, we need to add a canvas because we don't have anything right now. You can kind of think of this as like a painting. We need a canvas in order to actually add stuff or to paint, the picture of our UI. So we're going to grab our canvas and drop this onto our health bar widget. And now we actually have this canvas where we can actually add stuff onto it. So you can kind of think of this as like your computer monitor. So we're going to add like a little health bar on our player screen down here in the bottom corner of our screen. So under the palette, we're going to search for a progress bar. Progress bars are usually what you're going to be using for things like health bars or stat bars, stuff like that. So you can drag the progress bar. You can either drag it directly onto the canvas like here, or you can also drop it on the canvas panel over here. Either way will work. So we're going to just drop it like so right on the canvas. So you can see we have these little dots which allow us to actually resize the health bar. So you can click and drag, and then we can actually move it by just dragging on this, okay? So we're going to move it down to the bottom left of our screen. Okay, now you'll notice when we have this progress bar selected, we have the details panel over here populate with all the information about this progress bar. But the most important thing that you need to note is the anchoring position. Basically, the anchor is this little icon over here in the top, okay? You can see it highlights in green when I hover over it. The anchor tells us where should this UI widget anchor to? What corner of the screen should it anchor to? Because not everyone is going to be playing on the same monitor size. You know, someone could be playing with like a square monitor or an ultra wide monitor. Basically, the anchor is supposed to anchor the widget to that corner of the screen depending on what monitor the player is playing on. So we're going to, over here in the details, we're going to anchor. We want to click on the anchors and make sure that we choose the bottom left anchor over here, so that it will update the anchor position like so. That way this health bar will try its best to stay in the bottom left of our screen. Then the other setting we want to change is the actual percentage. So over here under progress, we have percent. So if we actually click into here, you can see that it changes the percentage of our health bar. Okay, so 1 is a full, we're full health. 0.5 is, half HP, and then 0 is no health. So we could just set this to, around 0.5 for now. We could also change things like the color. So over here we have appearance, fill, color, and opacity. So if you click in here, you can actually change the color of your health. So let's say we want sort of like a dark red color, and that should be good. So now we have our little health bar. Now what we want to do is we need to go ahead and actually show this on the player screen. So in order to do that, we'll need to compile this blueprint. First, we just need to compile this. This is a blueprint, so we'll need to compile and save that. And then we need to go into our third-person character. Okay, so in our third-person character, what we'll need to do is create this widget blueprint and then add this to our viewport. So for that, we'll need to use the event begin play. So we're going to right-click in our event graph and search for event begin play. And then basically when the game starts, we want to go ahead and create the widget health bar. So for that node, you want to search for a create widget. We're going to use user interface create widget. Okay. And so we can hook up the execution, and then it's going to have us choose a class. So in our case, we want to click the drop down and search for our widget blueprint underscore, and we should have our health bar widget. Okay. Now, whenever you're creating a widget, you want to assign this to a player controller. So we have this reference for owning player. So you want to right click and search for get player controller node, get the player controller. And we want to plug this in for the owning player reference there. And the reason why you want to do this is because the player controller basically needs to own this widget. We basically need to assign ownership to this widget. And then over here off the return value, what we need to do is we're creating it. Now we need to add it to the screen. So we'll call off of the return value, search for the node add to viewport. And we have this node add to viewport. This is what actually adds this widget that we just created to our viewport. Okay, just like that. So compile and save. And now when our player plays the game, we'll create the health bar widget and add it to our viewport. So let's go over here and hit play. And now you can see we have our little health bar widget on the bottom left of our screen. Okay, now if we actually run over here to the damage boxes, you'll notice that right now it's not actually updating the health bar widget. That's because we haven't set that up yet. So let's go ahead and actually set that up now. So let's go back to our widget blueprint health bar. And what we're going to do is in your widget blueprints, if you actually head over to the graph, we have these two different tabs over here. So we've kind of gone over the designer. This is basically where we can, actually lay out the widgets and, set the style and all that stuff. If we head over to the graph, we can click on this graph button over here. This will take us to the actual blueprint side of the widget. Because remember, this is a widget blueprint. That's what it means. We have a graph where we can actually program and add, logic for our widget. Okay, so in our case, we want to set up our progress bar to update. So if we actually head back over to the designer over here, this progress bar, under the percentage, we can actually add a binding, create a binding to update this percent. So this little link icon, if we click on it, we can create a binding, and that will take us over to, again, the blueprint graph over here. And it will also create a new function over here called get percent. So right now we're in this function called get percent, which basically outputs the percentage value. Okay, so we call get percent, and inside of here we can add the logic to return the percentage value. So what we'll need to do is get our character, get their health, and output the return value. So we're going to go ahead and expand this, and we're going to search for the node, right click and search for get owning player pawn node. So we have this get owning player pawn. Basically, if you hover over, it says it gets the player pawn associated with this UI. So basically, this will get our character who basically created this user interface widget. So off of this, we can now cast to our third person character blueprint, just like so. And we can hook up the execution. And now off of our character reference, we can get our health variable, just like so. And we can go ahead and use that for our percentage. Now this percentage value, this is a value of 0 to 1, okay? So we need to go ahead and basically shift the decimal point over because our health is a value of 0 to 100. So we want to convert this to percentage. So in order to do that, we can do a multiply and basically multiply our health by 0.01. And what that will do is we'll convert our health, which is a value of 0 to 100, to a percentage of 0 to 1. Okay, so we can plug that in for the final return and then just hook up the execution just like that. So compile and save. So now this get percent is bound over here to the percentage value. You can see we can no longer change the percentage because it's using this function get percent, which basically runs every frame, gets our character, gets the health, and returns that and sets the percentage of our health bar. So now if we actually hit the play button, you'll notice that when I hit play, it automatically gets our health, which is set to 100, and it updates the bar. So now our health is full, and our health is 100 out of 100 HP. So let's go to the damage box, and you'll notice that now it will update. So 90, 80, 70, 60, 50. You can see the health bar is at half HP because we're at 50 out of 100 of health. If we run into the health or the heal box, it goes up to 60, 70, 80, 90, and all the way up to 100. So that is basically our health and damage boxes. We created two separate boxes that can heal the player or damage the player. And we've also added a little health bar widget that actually shows the player's health. So now let's go ahead and work on the very next blueprint. So let's go to our content drawer over here. Let's dock this in the layout. Go to our blueprints folder here and right click and create a new folder. And this one will be called 04 underscore soccer blueprints. And let's go ahead and double click, open this up. All right, so in this folder, we're going to right click and create another blueprint class. And this is going to be of the type actor. And we're going to name this BP underscore soccer goal. Okay, so this will be our actual goal. Let's double click, open this up. And in here, we need to add a static mesh component for the actual goal mesh. So I'm going to add a new static mesh component, and we can, rename this to soccer goal. And then over here in the details under the static mesh, we can click the drop down and search for the goal. We should have this SM soccer goal, so select that just like so. Now we need to modify the material here because we have this net material. So let's compile and save this, and let's go to where this is located. So you can click this folder browse icon over here, and that will show us where it's located in the folder. And over here we have this net material. This is actually a material instance. So if we double click this, it's just these parameters. It won't actually allow us to modify this. So what we'll do is we're going to delete this. So delete this, or actually let's just create a new material. Right click, create a new material. Name this m_soccer net, and then double click, open this up. Then in here we'll need to drag in this mask. So drag this texture in and hover over the material and drop it on the graph just like that. And basically we want to change this color to be white, so just click on the base color and it changes value up to white. Click OK. And this needs to be a masked material because we want to have like this net pattern. So select the material over here. In the blend mode, we're going to change this to mask, and we're also going to click two-sided. Okay. Now this opacity mask open up, so we can just take this RGB and plug it in for the opacity mask. And now you can see we have this net material mask like so. So save that. Okay. And then close out of there, and then in our soccer goal blueprint, we can change the material here to that m_net soccer net. Okay, so it should look just like that. All right, let's compile and save. Now we need to add a collision box because we want to add a little trigger box inside of the goal to detect whether or not the ball was scored. So onto our soccer goal, we're going to add a box collision. Okay. And then we can scale this up by pressing R, and just scale this up just like so, and scale that upward and press W to move. And I think that should be good just like that. Okay, so compile and save. And now let's browse to this, find it in our content browser, and just drag and drop it in the level here. And we can go ahead and scale this guy down. So if we rotate this guy 180 degrees, press R, we can scale this guy a little bit down. Okay, something like that. And I'm going to take all of these stuff and move it over. Okay, and we can just move this over here for now. So we have our soccer goal blueprint. Now we need to create the actual soccer ball. So let's right click and create another blueprint class of the type actor. And this will be our BP_soccer ball. Okay, and let's go ahead and double click and open this up. So in here, we just need to have a single component. So add a static mesh, which will be our ball mesh. And then with that selected, let's change the mesh, search for ball. We should have SM ball. Okay, so it should be this soccer ball over here. Now, we want to actually scale this down because if we compile, save, and drag this in the level, you can see it's absolutely massive. So in the soccer ball, let's select the mesh and change the scale down to 0.1, just like that, and compile and save. And now it should be much smaller, yeah, just like that. Okay, so when we hit the play button, right now the ball is not going to move. Okay, you can see it's completely stiff. So we need to go ahead and enable physics on it in order for the ball to actually be pushed by the player. So you want to go to your soccer ball, select the ball mesh, and down here we can scroll down to the physics section. And over here we can actually check this checkbox to enable physics. That way it will simulate physics. Also, another thing we can do is change the mass, because right now it's set to 71 kg. So we can change this down to 20. And compile and save, and that should mess around with the ball's physics. So let's hit play here. Now it should simulate, and now we can actually push the ball into the goal. But you can see right now there's a couple of issues. Right now we can't actually push the ball inside the goal because of one, the collision, and also when we roll the ball, you can see that it doesn't really roll that smooth. It's very bumpy. Okay. So there's two things that we need to fix. Both are the collisions. So first, let's fix the ball collision. So if you go to the ball mesh here, select it, and click the browse icon, that will pull it up in the content browser. Let's double click and open up the ball mesh. This will open up this static mesh editor. In here, if we just see the collision, let's just visualize it. So go to the lit and change this to player collision. You'll notice that the collision is very blocky. Okay, so this is the reason why it's not rolling smooth on the ground. So in order to fix that, we can go over to collision, do remove collision, that will delete that. And now we can add a sphere simplified collision. Okay, so it adds this nice sphere. So save that, and now that should fix the collision on the ball. It rolls nice and smooth. Now we just need to fix the collision on the goal. So let's go over to the goal, select the mesh, browse to this, double click, open this up. Same thing, we can see that the player collision over here is basically blocking. There's no hole here. So let's go ahead, and one thing we can do is you could add some collision boxes and stuff. But one quick thing that we could do here is under the collision settings, down here in the details, we have collision complexity is set to project default. There's one setting you can use for using the mesh geometry as collision. You just click the drop down and use the complex collision as simple. What this actually does is it will use the mesh's geometry as the actual collision mesh. Okay, so you don't typically want to use this all the time, because sometimes when you have a very complex mesh, it's going to use a lot of CPU performance because it's using all the geometry of the mesh for the CPU calculation. So usually you want your collision meshes to be incredibly simple. Okay, but in this case, we're just going to save some time and use that setting. So save that, and now we can hit play here, and we should be able to actually hit the ball in the side of the goal, just like that. So now we need to actually set up the overlap, so when it hits the box collision there, it should basically play a little particle effect, say that we scored, and then respawn the ball. So let's go into our soccer goal blueprint over here, head over to the event graph, let's delete these nodes. Okay, and we want to select our box collision and scroll down, and we should have the event begin overlap over here. Basically, since we want to check and see if the ball actually was scored, and so off of the other actor, we want to cast to BP soccer, and you want to make sure, very important, we want to select the soccer ball, not the goal, the soccer ball. Okay, so it should be cast to BP soccer ball. Okay, so now that we've cast into the ball, we want to spawn a particle effect or emitter. So right click and search for the node spawn emitter at location. Okay, and let's hook up the execution, and we can set the emitter that we want to spawn in. So click the drop down, you can see we have things like explosion, fire. We're going to use this PKY hit 1 particle effect, and then you just want to define where you want this to be spawned at, the actual location. Okay, so we're going to use the get actor location node. So right click and search for the get actor location node. This basically gets the location of this actor that we're currently in, which is the BP soccer goal, and we can plug it in for the location. So compile and save. So now if we were to test this out, when the soccer ball overlaps and scores, we spawn an emitter at the actor location. So let's hit play here. Let's walk up to this and score this in here. And you'll notice that it played the little particle effect down there in the ground. Okay, because the location of the actor is this pivot point over here. Now let's say I actually want to modify that location, because let's say I want the particle effect to play above the goal, sort of like a confetti or firework or something like that. Okay, so the way that we can modify that is if we go back to the goal, instead of just using the actor's raw location over here, we can unhook this by alt clicking, and instead we can modify that position. So off of the location here, we can drag off here and do a make vector. So we have this make vector. And then off of the get actor location, we can break the vector. Okay, so now we have all three of the float values which we can modify. So we're going to hook up the x and y because those are, just the x and y, but the z value is the height. How high off the ground do we want this to be offsetted? So we can take the actor z and do a add operator, a number, let's say 300, units off the ground, and plug that in for the z, just like that. So now we're taking our original location, we're just adding to the z 300, and that's our emitter location we want to spawn. Let's compile, save, and let's hit play. And now if we actually score this, we should see that emitter above the goal, just like so. Okay, so that's how you'd modify the location. Now, once we've gone ahead and actually spawned the emitter, we want to go ahead and destroy the soccer ball because we want to respawn it. So off of this soccer ball reference, we can drag off here and do a destroy actor node. So right after we spawn the emitter, we'll destroy the soccer ball. And then we want to wait for a couple seconds and then respawn the ball. So for that, we're going to use the delay. So we have the delay node over here. Basically, this will wait for however many seconds. So we can say wait for 2 seconds. And then after it's done waiting, it will call this node over here, whatever we have hooked up. So in our case, we want to respawn the ball. So in order to respawn the soccer ball, we want to search for the spawn actor from class node. We have the spawn actor from class. That will spawn whatever class that we have assigned. So let's hook this up and let's go ahead and click the drop down and search for the BP soccer ball. And let's compile. And now when we actually compile this, you're going to notice that we have an error. So this is probably your first error. And whenever you have an error like this, you can see that for one, we have a red icon over there under our compile. It won't let us compile our blueprint, okay? It's not saying good to go because we have an error. And then in most cases, wherever you have that error, it will highlight the node. It will say error on it, okay? Also, the other thing is down here under the compiler results, it's going to show us the actual error message. Okay, so every time that you have an error, it's going to tell you exactly why you have that error and which node has the error. So you can see the current value of spawn transform is invalid. Spawn transform in action, spawn actor from class must have an input wired into it. So basically this spawn transform over here, it must have a input. Okay, so what that means is it needs to have some sort of spawn transform variable hooked up to here. Otherwise, it's going to give us this error. Okay, so the current value of spawn transform pin is invalid, and basically same exact thing. And again, it will tell you that this BP soccer goal blueprint had 2 issues, 2 errors, and you can see the exact path to it. So game blueprints, soccer goal. So it tells you exactly where this error is located. And also, if you click on this browse icon, it will show you exactly what node has the error. So whenever you run into an error, you don't have to panic because in most cases, it literally just tells you exactly what's the error down here in the compiler results. You just need to read the message and you can either look it up or you can just play around with the node. So in this case, this spawn transform needs a variable. So if we were to just drag this out, promote this to a variable, and then compile and save, you can see that that error message goes away. So whenever you use the spawn node, you need a spawn transform, okay? Another thing that I usually like to do is instead of actually using a spawn transform, you can also right-click and split this. So right-click this node and do split structure pin. That will add a location, rotation, and scale. So now if you compile and save that, you can see that we don't have an error. So usually I like to split the structure like that, and that just automatically gets rid of that error. Okay, now for our actual location, we want to get the location of the soccer ball. So what we're going to do is promote this to a variable. This will be our spawn transform location, compile and save. And then when the game starts, we need to save the spawn location of this ball. Okay, so wherever this ball is located. So what we could do is for now, we could just copy the location where it's at. Like over here in the details, we have the location of the ball. We could just copy that, go over to the soccer goal, select the variable and right click and do paste. and this would work. Okay, so now let's actually just test this out. So if we go into our level here, we should be able to score the ball, and it deletes it and then respawns. So let's go and score this. Okay, deletes it, and then after 2 seconds, it should respawn at this location. So that's great. We have all the logic working. However, the thing about this is, let's say if I were to move my goal around, to a different location over here, and let's say I want to move my ball all the way over here. Okay. So what happens if I go ahead and score the ball over here? Okay, will it respawn right here? Well, it actually respawn all the way over here. So what you'd have to do is right click and then recopy the location. So it's just a lot of back and forth. So one thing that we can do instead of this is we can just get the location of the ball in the level off of the event begin play. So let's go back to our soccer goal. And in here, we're going to right click and search for the event begin play. And what we'll need to add is another variable for the soccer ball reference. So we can add a new variable here, call this the soccer ball ref. And instead of having this be a Boolean, we can change this to our BP underscore soccer. We want to do the soccer ball object reference, okay? So now we have a reference to our soccer ball. So compile, save. We want to select this ball reference. And over in the details here, we want to set this to instance editable and expose on spawn. And then compile and save. And the reason why we're doing this is so that we can actually set manually the reference of this ball. So now if we were to go into the level and select the goal, in the details panel, we now have a parameter for soccer ball reference, which allows us to click the drop down and select manually the soccer ball that's spawned in the level. Okay. We can also use the color picker, the selection over here, and that allows us to select the soccer ball reference. So now you can see it's been assigned to the BP soccer ball. So now we have a hard reference to that soccer ball that's in the level. So this goal now knows about this ball spawn in the level. So now in the actual blueprint over here, we can get this soccer ball reference. First thing that we want to do whenever you have a reference like this is check and see if it is actually valid. So you can do a is valid check. This is valid over here. And the reason why you want to do that is because if this reference, if we forget to set this, if this is set to none, what it's going to do is it's going to throw up an error, and also it can also crash your game. So you want to do a is valid check. Okay. If it is valid, then we can get the actor location. So just off of this, get the actor location of the soccer ball, and then we can actually save this. So we have our spawn transform location vector. We can set that on the graph, hook that up for the is valid, and then take our actor location and save that to that variable. So now compile and save. So off the event begin play, we get our soccer ball reference, check and see if it's valid, get the location and save that, which we can then use to respawn the ball at its spawn location. So now in our level, make sure that the goal has a reference to the soccer ball, just like that. And now if we hit play, we can go ahead and score the ball. Okay, and it should automatically respawn it right there. And this will work for whatever position. So let's say again, I move my soccer ball over here. Okay, and we move the ball all the way over to here. Okay, it will save that location depending on where I place it in the level. Okay, so it should respawn right there. So this is one way that you could do this. You could just have a reference that is exposed. That way you can manually set the reference, and now this soccer goal has a reference and knows about the soccer ball. Okay, so those are basically our soccer goal and soccer ball blueprints. The last blueprint that we're going to create is our hit actor blueprint. So let's go over here. Let's close all of our tabs. So close all tabs to the right. That will close all those tabs. In our blueprints folder, let's go ahead and dock this in the layout, create a new folder, and this will be the last blueprint that we want to create, which is our 05 underscore hit actor blueprint, just like that. And then inside of here, we're going to right click and create a new blueprint class. of the type actor, which will be our BP underscore hit actor. Now basically with our hit actor, let's go ahead and actually double click open this up first. In here, this is going to be like a little spinning obstacle that the player will have to dodge. And if it hits the player, it will send them ragdoll flying. So in here, we're just going to add a simple static mesh component. And for the static mesh, we want to click the drop down over here and search for the hit SN hit actor. Okay, so it's basically just this spinning hammer. So if you press E, it's going to rotate just like this, around and around and around and around, over and over. And when it hits the player, it's going to send them flying. Okay, so that's what we want to create. So in order to detect whether or not we hit the player, we're going to need to add a little capsule component over here to detect whether or not we hit the player. So onto our static mesh, let's add a capsule. Should have capsule collision. Okay, and then we should have this little capsule over here. So we want to go ahead and press E to rotate this, 90 degrees. Whenever you rotate this, we want to switch this to global space. Right now we're in local space. So change this over to global space. That way the gizmo is lined up with the grid. So now press E. We should be able to rotate that 90. Then press W. We should be able to move this up and over. And let's scale this guy up and move this guy over. Okay, something like this. And if you want to turn off your grid snapping, we'll disable it like so. Basically, I think this should be about good. Okay, something like this. Doesn't have to be super perfect. And you can change this to local space or world space, and that should allow you to scale it like so. So just play around with the local and global space tool there, and I think that should be good. It just covers this little actor. So when this little component hits our player, we can add that event, the detection. Okay, so compile and save. Now the other thing I'm going to add is a arrow component. So onto the capsule, we're going to add a arrow. So this is going to just tell us which direction the actor is spinning. So we're going to move this arrow component and rotate this 90 degrees. And we're going to place this somewhat in front of the hit actor, okay, like that. Okay, and then finally what we need is actual rotating movement. So we want this thing to rotate around. And for that, Unreal Engine has a built-in component that handles rotating. So under the components, just search for rotating movement. And we have this rotating movement component, okay? And what controls the actual rotation rate, like how fast it rotates. In the details over here, we have this rotation rate value. Right now it's set to 180 degrees on the Z, which is what we want. And a higher number would speed that up, a lower number would slow that down. Okay, so compile and save. And now let's just drag this into our level here. And if you hit play, you can see that it's now rotating around. Okay, so now what we want to add is the ability for it to actually hit our player. Right now it's not doing anything. So when this collision capsule hits our player, we want it to launch the character and send them flying. Also ragdoll the character as well. So let's head back over to the hit actor. And in the event graph, we're going to delete these nodes that it gives us. And we're going to select our capsule over here, the collision. When we want to scroll down and add the event on begin overlap. So event on begin overlap. When the character overlaps with the actor, we're going to cast the character. So off the other actor, we'll do a cast to third person character. Make sure that it's the character. And we want to call a event inside of the character that will basically do all the logic. So we want to go to our third person character blueprint. So let's go to third person blueprints, open up the third person character. Okay, so down here on our event graph, we want to right click and add a custom event. So just add a custom event, and we're going to name this to hit by hit actor. Okay, something like that. And then we also want to pass some information to this event, like where we hit, what direction. So under the inputs over here, we're going to add a new input. And instead of this being a Boolean, we're going to rename this to hit location and change this from a Boolean over to a vector. okay, because we want a location. So compile and save. And now let's actually call this from inside of the hit actor. So go back to the hit actor blueprint, and in here we can, off of the third person character, we can call that event. We can call the hit by hit actor event that we just created, and now we should be able to call that. And so for this hit location, we want to basically get this arrow location, because this is the hit location. This is exactly where we hit the player. So we're going to get this arrow component on the graph, and then we can get the location of that. So we actually want to use the get forward vector, because this will get the forward direction in the world. So let's go ahead and select that. And this return value will plug in for the hit location just like that. Okay, so compile and save. So now we're getting the forward vector of the arrow, which gives us the direction of where we were hit. And now we can click on this, and this will take us to our character where we have the hit by hit actor event. So for this, what we'll need to do is compile, save this. We'll need to add our simulate physics because we want to have our character ragdoll. So we're going to take our character mesh component over here. We want to get that on the graph and do a set simulate physics. Okay, and we want to hook this up and set this to true to simulate our character's ragdoll. Okay, and in order for this to actually work, we need to update our character's collision settings. So you want to go to your viewport, select the character, and scroll down under the collision settings. Over here we have collision presets. Right now it looks like it's set to custom, and we're going to have to change this. Okay, under custom, instead of use custom, we're going to do ragdoll down here. I'm going to choose ragdoll. And what that will do is it will allow us to actually simulate physics on our character. Okay, so if we don't do this, then it won't allow us to have our character ragdoll. Okay, so now in our event graph, we should set simulate physics, ragdoll our character. And then we want to go ahead and launch the character. So again, we're going to get the character mesh component. And off of here, we're going to search for the node add impulse. We have this physics add impulse node. Okay, so what this will do is it will add an impulse depending on the location that we want to feed. So off of this impulse, we want to do a make vector. We have make vector over here. And for the X, Y, and Z, what we'll do is we'll take the hit location and we're going to multiply this. Do the operator multiply. And instead of multiplying this with a vector, another vector, we can right click the pin and we can do a to float like that. Okay. And what that will allow us to do is it will multiply the hit location by the single float. And so for this float value, we're going to do something super big like 50,000. Okay, so that will send our character flying. And then we're going to break the vector of that, and then plug in the X and Y to the make vector. And then finally, we're just going to add some value over to the Z. I'm going to set this to, like 50,000, just like so, in the Z direction. So basically, it should just send the character flying, okay, in the air based on the hit location. So that will add the impulse. Then the other thing we want to do is we want to disable our character movement, because this is going to send the mesh flying, but our character capsule in the movement component will still be able to run around. So we're going to take our character movement component and do a disable movement. Okay, so that will basically stop our character from being able to move. So now let's compile and save this. And if we actually test this out, when we overlap with the hit actor capsule, when it hits the player, we're going to call the hit by hit actor. Basically, that simulates physics on our character, so we can ragdoll. And then we add an impulse so we can send our character flying. And of course, we disable movement. That way our player can't run around. So let's go ahead and hit play. And let's run up to the hit actor. And if we let this hit us, it should send our character flying. And you'll notice that we can't move anymore. We can still move our camera around, but we can't move our character around. Also, another thing is, if we go over here, you'll notice that it keeps hitting our player over and over and over. So let's say if we were to run over here again, it keeps overlapping, and you can see our character's body keeps flinging over and over. So basically, we want to modify the logic because we don't want it to continuously hit our character over and over. We want it to reset and also hit our character once, only once. So we're going to go back to our third person character because we need to modify the logic. So what we're going to do is we're going to unhook this execution. So do Alt and click. And we're going to add a Boolean variable to check whether or not the character has been knocked out already, because we don't want the hammer to keep hitting our player over and over. So we're going to add a new variable in here called is knocked out question mark. Is our player knocked out? Compile and save. And then we're going to get this Boolean variable, and off of this we can do a branch. We can basically check the condition whether our player is knocked out or not. Okay, so we're going to hook up this for the execution. Now, if the player is knocked out, we don't want to, hit the player again or launch them again. Now, if they are not knocked out, we want to set this Boolean variable to now true because now they are knocked out, because now we're going to simulate physics. So I'm going to get this Boolean on the graph, do a set, and hook this up only for the false. Okay, if they're not knocked out, now they are knocked out, set that to true, and now we can simulate physics, launch the character, and disable movement. Okay, so compile save. So this branch basically only allows us to get hit once. Okay, and now we need to actually set up the reset logic. So basically, after we disable movement, we want to wait for a couple seconds and then reset the character. So we're going to do off of here, do a delay. We'll use the delay node, and we can set the duration for, say, 5 seconds. Okay, and then after 5 seconds, then we can reset the character. So compile and save. So for this, what we're going to do is down here, we're going to add another custom event. We can right click and add a custom event. Okay, just like that. And we can name this reset character. Okay, so compile and save. And now we can just call this event from over here. So off the completed, we can call reset character. Okay. And after 5 seconds, it should call the event down here to reset our character. And basically what we want to do to actually reset the character is do the exact opposite of this. Okay. So we want to basically get our mesh, character mesh, and set simulate physics. We want to set this back to false. Okay. So we can unsimulate physics. And then we have to reattach our character mesh to the capsule. So in order to do that, we're going to get our character mesh and search for the node attach component to component, because we need to reattach our character to the character component. So we have our mesh. We want to attach it to the capsule component. So drag and drop that and hook that up for the parent. Then we want to, for the location, rotation, and scale, do snap to target, just like that. And that should reattach our character mesh to our capsule component. Lastly, we need to set the rotation and location of our character mesh, because if we were to just attach it back, it's going to be offsetted at a weird location. So for that, you just get your mesh, character mesh, and do a set relative location and rotation. And that will set the relative offset of our character mesh. Okay, so hook this up. And if you want to find the default location and rotation, just go to the viewport, and the current location and rotation offset of our character is what we want to use. So you can see right now it's set, the location is set to -89 on the Z, and rotation is set to 270 degrees on the Z value. So this is our default offset position. So we come over here and set that. So for the location, this is -89 on the Z. And then for the rotation, this is 270 degrees on the Z. Okay, so that will basically reset it back to the default. Then finally, we want to undo our disable movement. So for that, we can get our character movement component, and we're going to do set movement mode, character movement, set movement mode, and we're going to set this to the walking movement mode. So that will basically undo the disable movement, will re-enable our character movement. And then finally, the last thing that we want to do is we want to set is knocked out Boolean. We want to set this back to false, just like that. Okay, so that will reset this little gate. That way we can get hit by the hammer again in the future. So now all that we're doing, just to summarize what we're doing, when we get hit, We check and see whether our character's been knocked out. If they have been knocked out, we're not going to do anything. However, if they have not been knocked out, then they are now getting knocked out. So I'm going to simulate physics, add an impulse, disable movement, wait for 5 seconds, and then reset the character. So we want to reset character, we unsimulate physics, we reattach the character mesh back to the capsule component. We then set the relative location and rotation offset, that way it's reset to the default. Then we re-enable the character movement so they can walk. Then we set the is knocked out back to false so that the character can be hit by the hammer again. So now let's go ahead and actually test this. Let's hit play over here. And if we run up to the hammer, we should be able to get hit once. You can see it overlaps with the character over and over, but it doesn't get hit again. And then we reset our character. It reattaches our character back to the capsule. And now we can actually run around and we can go back up to the hammer and get hit again. Okay. So basically it will hit us only once and we can respawn just like that. So that is our hit actor. Now what I want to do is, let's say we want to actually go ahead and duplicate this. So you can hold Alt and drag, and that will actually duplicate these actors, okay, in the level. If I actually go ahead and play the game, you'll notice that all these hit actors spin at the same rotation rate. Let's say I want them to be randomized so that they spin at different rates and also maybe different directions. How could I actually go ahead and do that? Okay, if I were to modify the hit actor, rotation movement, it's going to update it for all of these spawn in the level. So one way that we could actually do that is by adding a exposed and modifiable variable. So if we go into the hit actor over here, we're going to add a new variable, and this is going to be the rotation rate. And we're going to need to change this from a Boolean over to a rotator and compile and save that. Now for this rotation rate, we want to set the rotation rate of the rotating movement component. So we're going to search for the event begin play node. So when the game starts, we're going to get the rotating movement component, and we're going to set this rotation rate over here. So we're going to, off of the rotating movement, search for set rotation rate, and now we can actually set the rotation rate of the rotating movement. So hook up the execution, and for the rotation rate, we want to plug in the rotation rate variable that we just created. Okay, compile and save. And now to actually modify this variable at runtime or in the editor, we want to set this to instance editable and expose on spawn. Okay, these are the two magic settings. So compile and save. And now if we go into our level and select one of these hit actors, in the details panel, we should have a new parameter called rotation rate, which we can manually adjust per instance. So each of these we can manually adjust. So let's say we want to set this to 180. Then maybe we want to set this one to negative 180 for the rotation rate. And then maybe this one over here, we can set this to, 190. And then over here, we can set this to maybe, negative 90. Okay, so now we've set manually each one of these different rotation rates to different values. So now if we hit play, you can see that all of these are spinning at different speeds. Okay, some of them are even spinning at different directions, just like that. So basically, that's what it allows you to do. If you create a variable in here and expose that on spawn, make it instance editable, that means that you can now edit and expose that property. And depending on how many you have of these spawn in the level, you can change them per instance and have custom variables for each separate blueprint actor. So that's a very powerful thing about blueprints, the fact that you can change the parameters per instance. So those are all the blueprints that we've created in our Blueprint for Beginners series. We created a very simple first blueprint that prints off hello world. We created a door that the player could open and close. We created a hat pickup that the player could equip onto their head, damage and health boxes that damaged and healed the player, a soccer goal and soccer ball, and a hit actor that can hit the player and send them flying and ragdolling. So this video is the first in my blueprint series, so I'll likely be making a follow-up video called the Blueprint for Intermediate Users, which covers over some more intermediate topics like arrays, structures, and more different types of variable types. So if you guys want to see that video, make sure that you subscribe for that. Also, if you want to learn more about blueprints and making games inside of Unreal Engine, I have a bunch of courses on my website at smartpoly.teachable.com. So go ahead and head over there to learn more. And that's pretty much it for this video. So hope you guys enjoyed, and I'll see you guys in the next one.